What's up, guys? Welcome back to the channel. Today on this video, we'll be doing this question paper that you see here. So this is a national certificate for mathematics and 4. And this paper was actually written on the 24th November 2025. It was an X paper, which took about 3 hours to be written. So I'm going to leave timestamps on this video just in case you want to watch this question paper or this memo in a order that you like. All right, guys. So before we start though, you can always share, like, subscribe to the channel, and also comment if you have any comment. All right, people. So let's go to question 1 and let's do this question paper. Here's our question 1. As you can see, question 1 has 3 questions, which is 1.1, 1.2, and 1.3. So these questions, they have their own sub questions underneath them. So question 1 is actually graphs and functions. So we're going to start with 1.1, as you can see there, and then we're going to do it. So what I'm going to do is I'm going to create space, and then we do 1.1. So here's our 1.1. So the question goes like this. Draw a neat sketch of the graph of y plus root 9 minus x squared is equaling to 0. Now, this graph here, guys, it's actually the semicircle graph, just in case you know. So what we have to do here is we have to make y subject of the formula. Let's do it. We say y is equaling to, if you transpose all of this to the right-hand side, this is going to be negative root 9 minus x squared. Right. So this here, guys, is actually the semicircle graph. Just in case you didn't know, the semicircle graph looks like this, especially for one with y. Just write it here. The general formula, it looks like this, plus or minus. And then we have r squared minus x squared. This one is for y. Based on this question that we have here, wherever we have r squared there, we have 9 there. It means here our r squared is equaling to 9, right? So in order for us to find r, we have to square root there, and then r is going to be equaling to 3. So this here, guys, is our radius. Now, let's look at the signs there. We have the sign which is negative there. When the sign is negative, this basically means that our semicircle is going to cut on the negative side of y, right? Since it's equaling to y. So let's draw our Cartesian plane. All right, so here's our Cartesian plane. Since our radius is 3, we can just insert the point where 3 is positive and negative 3 on x-axis, positive 3 and negative 3 on y-axis. So, like I said, this is a semicircle, but it's cutting on y. So this is a lower semicircle. Because of this negative here, this semicircle is going to cut on the negative side of y. So when I have this point here, and that point there, and this point there, and then we connect these dots. There we go, guys. So this is our graph. You can name it y is equaling to negative 9 minus x squared. That is our graph here. So this here is out of 2 marks. Guys, do not forget, whenever your semicircle graph is equaling to y, just know it's cutting on the y-axis. But then if it's negative, it's cutting on the negative part of y-axis. Okay? If it's positive, then it's going to cut on the positive part of y-axis. So this is a lower semicircle. All right, people. So this is how you do this one. Just in case you didn't understand, you can leave a comment in the comment section. But if you did understand, you can also like, subscribe to the channel if you haven't subscribed, share the videos to your friends, and also, guys, recommend people to the channel. All right, we are done with this 1.1. Let's go and do 1.1.1. All right, guys, here's our 1.1.1. Let me highlight it here. As I said, 1.1.1 is a sub-question for 1.1. Now, the question is so simple here. They say there is the inverse of y plus root 9 minus x squared is equaling to 0, a function or a relation. Now, this one here, guys, you have to be careful when you do this one. They're asking whether the inverse of this graph is a function or a relation. Now, the inverse of this graph here, there are two ways of writing the inverse. It's simple. You can swap x and y, and that's going to be your graph. Let's say the inverse of f of x. So what we have to do there is swap x and y. So from this here, from this equation, we substitute by x, and then this is going to be equaling to negative minus y squared. All I did here, I just swapped x and y, and that's it. So you can draw this graph to see whether it's a relation or a function. Now, if I were to draw this graph, I will know that our r here is gonna be 3 as well. This here, right? The square root of 9 is 3. Now, since it's equaling to x, this basically means that we're gonna cut on x-axis. But since it's negative here, this means that we're gonna cut on the negative side of x-axis. So still we're gonna cut at -3, +3, and -3. So we're gonna cut on the negative side of x. So this one here is our inverse graph, the blue one there, guys. So the blue graph that you see there, that is gonna be our inverse. Now remember, they never said draw the graph. I'm drawing this just to explain how I'm answering the one of the answers there, because we need to select whether this inverse it's function or relation. The answer here is relation. There we go. So the answer for this one here, it's relation there. Why is it relation? Well, one of the reasons we cut y twice. If it's a relation, guys, the graph will cut y twice or more. So as you can see, the blue graph there is cutting the y-axis twice there. So another way to find out whether this graph is a function or relation, you check within the domain of the graph. Okay. For example, if we draw a vertical line within the blue graph, which is the inverse, if we take any x value, let's say -1, and we draw a vertical line within the domain of this blue graph, we're gonna have this point here. Okay, so this point, obviously our x is gonna be -1, and our y, for now, let's just say it's just positive y. Again, if you extend this line going downwards, we're gonna have a point that cuts again the blue graph, but this time around, we're gonna have x is -1, and our y is gonna be just be negative there. Even though we don't know the exact value of y, but this states that one x value gives you 2 y values. So this is one of 2. It's another method that you can use to check whether the graph is function or relation. So this also proves that our graph here, the inverse, is a relation. I hope you guys managed to understand this one. Again, if it so happened that you didn't understand, you can leave a comment in the comment section. You can also like the video if this video helped you to understand. And if you haven't subscribed, subscribe to the channel. And don't forget to share the videos to your friends. All right, people, we are done with this question 1.1.1. How about we look at 1.1.2? All right, guys, we are done with 1.1.1. Let's look at 1.1.2. Now, the question here states that is the inverse of y plus root 9 minus x squared equaling to 0 continuous or discontinuous? So the question here, they are asking, is this the inverse continuous or discontinuous? If you still remember, the inverse look like this. By the way, I did erase it earlier, the blue graph there. So the question is it continuous or discontinuous? So the answer is continuous. I'll explain to you later on. Let me just write continuous there. Right. So it is continuous because you can draw this blue graph without breaking a line. When a graph is continuous, it's when you can draw it without breaking a line. Let me draw the Cartesian plane and make an example here. We have a graph like this one here. We can say this is a straight line graph, right? This is a straight line graph. As you can see, this graph that we just drew there, you can draw it without breaking a line. You can just draw a line that is going straight without you lifting a hand or breaking a line. So when it's like that, it's continuous. As you can see, going back to the question, the inverse graph of this one that is given to us, it is continuous because you can draw it without breaking a line. An example of a graph that is not continuous, it's the one that follows now. Let's say we have a hyperbola. Remember hyperbola? A hyperbola like this one here. In order for me to complete this graph here, I have to break the line and draw another part on the fourth quadrant. So in order for us to draw this graph here, we have to break the line, okay? So this type of a graph here, it's discontinuous. But as for this one here, that is continuous. So I hope you guys understand, because these are free marks, guys. They're very easy to get, very easy to understand. They're just free marks. So just in case you didn't understand, you can leave a comment on the comment section. Even if you did understand, guys, you can comment as well. And if this helps you to understand better, do not forget to like and subscribe to the channel if you haven't subscribed. Don't forget to also share this information or these videos to your friends. All right, people, we are done with this one. It was straightforward. All right, guys. So here's 1.2. Now, this is a different question on its own. They want us to draw or sketch a graph of 9x squared is equaling to negative 4y squared plus 36. So this graph that you see here, we need to simplify it, guys. How about we take this negative 4y squared to the left-hand side? On the left-hand side, we have 9x squared, right? If we take this negative 4y squared to the left-hand side, it's going to be positive 4y squared. And then on the right-hand side, we're going to be left with 36 there. Now, when it's like this now kind of look like something that you are familiar with, which is an ellipse, right? Remember, let me just write the formula here for an ellipse. Ellipse is like this. You have x squared divided by a squared plus y squared divided by b squared. This is equaling to 1, right? So as you can see, we do not have the equaling of 1 there. So we need to make it to be equaling to 1. So when you do that, we must divide by 36 throughout all the terms there. We divide by 36, divide by 36. If you divide by 36, on the first term, we will have x squared divided by 4 plus, and then on the second term, we're going to have y squared divided by 9, and this is equaling to 1. Now, this kind of look like this now. As you can see, a squared is dividing x squared. From our equation here, our a squared, we can say, is equaling to 4, right? And then our b squared, the one that is dividing y squared from this equation there, it's 9 on this one. Now, let's continue. Let me create a little bit of space here so that we can able to solve this problem. So we know that in order for us to find a, we need to square root a and also square root 4. Same thing here with b squared. We square root b squared and 9. So a is equaling to plus or minus 2 because the square root of 4 is 2. And then b is equaling to plus or minus 3. Now, going back to our equation there, just create a space, our general equation. I hope you can see, guys. Going back to this equation there, as you can see, we have a squared, which is dividing x squared. So a is actually the x-intercept. We have b squared that is dividing y squared, meaning b is the intercept of y. So let me draw the Cartesian plane and let's draw the graph. All right, so here's our Cartesian plane. As you can see from our calculations, a is plus or minus 2. And we said a, since it's dividing x, is the x-intercept. So on the x-intercept, you're going to write in 2 there and negative 2. There we go. That's for x-intercept. And then for y-intercept, we have b there, which is plus or minus 3. So we're going to have positive 3 there and negative 3 there. And then from there, you connect the dot. Remember, the ellipse, guys, is a graph that looks like an egg. Just in case you didn't know, guys, it looks like an egg like this, right? And then here, let me just do this. Then here, the intercept there, it's B, and that is going to be negative B. And the intercept there, it's A, and that is going to be negative A. There we go. Just in case you didn't know. So in our case, our A, it's plus or minus 2, and then our B is plus or minus 3. So let's connect the dot. Let me use a different color there for us to draw the graph. There we go. So here is our graph. So this is then ellipse, the graph that they wanted you guys to draw. So make sure that you show this intercept because it's very, very important. And then don't forget to label the graph as well. Well, you can label it from the original equation or the one that you just simplified into. So I'd rather label it to the one that I just simplified into. Still okay. There we go. So this is our ellipse there. So this is out of 2 marks. So some of the things, guys, are not necessary for you to do them. It's just for me to explain to you guys. Anyway, I hope this part of the video helped you to understand. If you do not understand, again, guys, you can leave a comment on the comment section. Even if you did understand, comment in the comment section. And if this video helped you to understand better, you can always like, share, and also subscribe to the channel if you haven't subscribed to the channel. All right, people, we are done with 1.2. Let's look at the next question. All right, the next question is as follows. It's 1.2.1. They want you here to tell us what is the domain of the graph 9x squared is equal to negative 4y squared plus 36. What is the domain? When they ask about the domain, they're actually asking about the x values that are part of this graph here. So as you can see, our x values here on this graph, it's actually 2 and negative 2. So basically they're asking from x-axis, where does it start? Where does it end? This graph of ours. So the domain is actually negative 2 to 2. You can write it like this. This is fine, guys. This is our domain from this negative 2 to 2. That's it. So whenever they talk about domain, they're actually asking you to give us the values of x that are part of the graph, right? So we can also write x is the element of real number there. It's fine. Even if you don't write it, I don't think it's going to be a problem. This is out of 1 mark, guys. I hope you guys understand how to get the domain here. Let's look at the next question. As you can see, here's our next question, 1.2.2. Now, the next question, they're asking, what is the range of the graph 9x squared is equal to negative 4y squared plus 36? The very same graph that we just drew there. Now they're asking about the range. Again, guys, the range, we are looking at the y-axis. So we're looking for the values of y, where the graph starts and where it ends. Now, as you can see, this is going to be negative 3 and 3. So the range, you can write there, range is from negative 3 to positive 3. Y is the element of real number. There we go. So this here, guys, is the range. It starts from negative 3 to positive 3. So that's how you're going to get the range. So whenever they talk about the range, it's on the y-axis. So I hope you guys understood how to answer these two questions. They're not really that difficult for this one. It's really straightforward. But just in case you didn't understand, again, you can leave a comment on the comment section. I'll try to answer it to my level best. Even if you did understand, you can always comment, like, share, and also subscribe to the channel if you haven't subscribed to the channel. Well, people, we are done with 1.2. I think it's time for us to do 1.3. So let's look at 1.3. All right, let's look at 1.3. Now, 1.3, they want us to draw a new graph of y is equal to log base ex. So this is actually a log graph. So this one here, this log graph is the same as y is equal to ln x, right? Just in case you didn't know, guys, ln x is equaling to log base e then x, which is the same question that we have there. Right, so it's up to you how you're going to draw this graph. You can draw it that way from the original equation, or you can draw the ln x graph. But it doesn't matter. What matters is how you draw the graph. So I usually tell people to use the table. I find it easy to use the table, guys. Please use the table as long as you understand it, use it. I'm going to start by putting 0, 1, right? 0, 5. We put 1 and we put 2 there. Guys, these values that I put here on x, as long as they are positive, they are fine. As long as x is greater than 0, that's good. Please do not put x that is less than 0. You can put an x that is greater than 0. X cannot be equaling to 0 again on this one. Let's put this on a calculator. When x is 0, 1, what is our y? This is going to give us negative 2, 3. There we go. So when x is 0, 1, it's going to give us negative 2, 3. When x is 0, 5, what is it that you're going to get there? We're going to get negative 0, 69. Let's just make it 7 like this. Okay. Now, when x is 1, what is going to be our value there? Our y is going to be 0. And then when x is 2, what is going to be our y there? It's going to be 0, 69. Let's just make it 0, 7. There we go. Now let's do the Cartesian plane and let's draw our graph here. Here's our Cartesian plane. Now let's start with this first point here. When x is 0, 1, what is our y? Our y is going to be negative 2, 3. So 0, 1 for x is very close to 0. Let's say it's somewhere here. So we have to draw a line that goes downwards like this, right? Vertical line, guys, right? Our y is going to be negative 2, 3. So negative 2 is here, 2, 3 is in the middle, somewhere there. Also draw a line that goes there. Wherever these lines meet, this is our point there. I hope you guys can see, right? Then let's look at this point here. When x is 0, 5, what is our y? Our y is going to be negative 0, 7. So 0, 5 is here. You draw a vertical line again here. Negative 0, 7 is very close to negative 1. So it's somewhere there, guys. There we go, this point there. And then when x is 1, our y is 0. This is the point there. So this is going to be point here. Our x is 1, our y is 0 on the x-axis. There we go. And then when our x is 2, this is 2, our y is going to be 0, 7. 0, 7, let me draw a line first here. Okay. And then 0, 7 is very close to positive 1 there. Wherever they meet, this is going to be our point. Then from there, you just connect the dots. So let's connect the dots. There we go, people. So this is our graph for the log. Just in case, guys, you don't know how to draw this, rather use the table method. It's easy, straightforward. Might take you some time, but it's not that difficult to follow. Okay. So some of you may ask, why don't we have negative x on our table there? It's because our graph asymptotes. As you can see, our graph doesn't pass the y-axis. It asymptotes on y-axis. So if it asymptotes on y-axis, it means it doesn't go on the negative side of x. It means it doesn't pass to the negative side of x. So this is our graph. So one of the most important thing that you must always show this point here. Let me just write it. 1 and 0. When x is 1, our y is going to be 0. Show this point. Another thing, the shape is very important. Exactly the way I've drawn it should be like that. Your graph should not cut y. Once it cuts y, it's incorrect, especially for this one here. So it only asymptotes at y-axis. Right. And another thing that you must not forget is to label the graph. So this graph here, it's actually y is equaling to log base ex, or you can write it as y is equaling to ln x. One of the two, it's okay. Right. So this table here, it is not necessary as long as if you know how to draw the graph. If you don't know how to draw the graph, rather use the table. Guys, we are done with question 1. I hope this video helped you to understand this question 1. Just in case you didn't understand this question here, 1.3, please do not hesitate to leave a comment in the comment section. I'll try to help you to my level best. But if this video helped you to understand, don't forget to like, share, comment, and also subscribe to the channel if you haven't subscribed to the channel. Right, people. Next time we'll be doing question 2 of this question paper. All right. Here's our question 2 here. Now, as you can see, question 2 consists of 5 questions. And question 2 is mostly complex numbers and determinant. So we're going to start with 2.1 and we continue and do 2.2, 2.3, 2.4, and 2.5. So let me just create a space and then let's do 2.1. All right, people, here is question 2.1. Now let's look at the question. This says solve for x if you have the matrix there. So that matrix has x there, and this matrix is equaling to 4. So, guys, we're going to solve for x by using the method that we use when we calculate the determinant. So, usually when we calculate the determinant, we say d. In this case, our determinant is 4, right? It's going to be equaling to, you multiply the first entry with the last entry there. So, our first entry is 3 multiplied by x. There we go. Then you subtract, open bracket. Then inside this bracket, you multiply the second entry and the third entry, which is -1 multiplied by 2. There we go. If we continue, we still have 4 there on the left hand side, and then we have 3x here. And then inside there, we have -1 multiplied by 2. This is going to give us -2. There we go. If you continue again, we're going to have 4 there, and then we have 3x, and then we have negative multiplied by negative. This becomes +2. And then from there, we need to transpose this +2 to the left hand side. So let's do it. So we're going to have 4 minus 2, and then we have this equaling to 3x. 4 minus 2 is 2, and then on the right hand side, we'll have to 3x. So we divide by 3 throughout. Let's divide by 3, and then x is equaling to 2/3, because this 3 and that 3, they will divide each other. You'll be left with 1. So that is our final answer. I hope you guys managed to understand this, because this is actually the method that we use to calculate the determinant. Just in case you don't know how to calculate the determinant, I will leave a video that shows how to calculate the determinant. So you can go to the description and click on that video. And also the video will pop up on the top right of the video that you're watching at the current moment. All right, people. Again, if this video helped you to understand, do not forget to like, share, and also subscribe if you haven't subscribed. If you have any question or any comment, you can comment in the comment section. That would be highly appreciated. All right, people, we are done with 2.1. Let's go into 2.2. All right, guys, here is our 2.2. Now let's look at the question here. Given we have x is equaling to -3/2y plus 9/2. And then the second expression or equation, we have x, which is equaling to 4y plus 2. So as you can see, these two equations here, we need to rearrange them. So let's start with the first one there, this one. When we rearrange, we need to transpose this -3/2y to the left-hand side. So let's do that. So we're going to write x, right? If we transpose this -3/2y, it's going to be +3/2y. There we go. And then on the right-hand side, we're going to be left with 9/2. So this is the first equation. So the second equation, again, we need to rearrange it. We're going to transpose this 4y from the right-hand side to the left-hand side. So this equation here is going to be x minus 4y. All this is going to be equaling to 2 because you only left with 2 on the right hand side for equation 2. So let's look at these two equations here. Guys, I would advise you for both this equation, if you are given in this manner where you need to rearrange your equations, make sure that the first terms of these equations are x variables and the second term of this equation are y variable, of course, on the left hand side. And then make sure that everything is equaling to the constant. As you can see, equation 1 and equation 2, they are equaling to the constant. Equation 1 is equaling to 9 over 2, and then equation 2 is equaling to 2. Now, with that being said, we have to create the matrix here. So, lucky enough, this is a 2 by 2 matrix. So, when you create the matrix, this is going to help us to calculate the determinant. So, let's calculate the determinant, right? So, let's calculate the determinant. Now, when you create the matrix here, guys, you only take the coefficient of x for the first column because the first column represents x, guys. Let me just write x here. First column represents x. So if you look at the coefficient for the first equation, it's 1. So we write 1 there. And then if you continue and write again for the second equation, the coefficient is also 1, right? And then let's look at the second column. The second column represents the y coefficient. So if you look at the second column or the second term, the coefficient there of y on the first equation is 3 over 2. There we go. Then the second equation, when you look at the coefficient of y, it's negative 4, right? And then that's it. I hope you guys can see this. I hope you understand. All right. So basically what we did here, we took the coefficient of x for first equation and the second equation, which is 1 and 1, and the coefficient of y from the first equation and the second equation, which is 3 over 2 and negative 4. I hope you understand, people. So we're going to use this matrix to calculate the determinant. Again, when you calculate the determinant, guys, remember you have to multiply the first entry with the last entry, which is going to be 1 multiplied by negative 4. There we go. And then minus. Remember, put it inside the bracket and close that bracket. And then the second bracket, you must multiply the second entry and the third entry, right? So it's 3 over 2 multiplied by 1. There we go. Then from there, you use your calculator. On the first one here, we have 1 multiplied by negative 4. This is going to give us negative 4. And then minus. And then we have 3 over 2 multiplied by 1. It's going to give us 3 over 2. Then if you put this on your calculator, your determinant here is going to give you negative 11 over 2. So this determinant, you're going to use it later when you're calculating for x and y. Let's not forget the question says solve for x and y by using the method of Cramer's rule. So this D, we're going to need it a lot. All right. So now that we are done finding our determinant, we need to find the determinant of x, right? So how are you going to do that? Let's go back to our original matrix, this one here, okay? I hope you're paying attention to it. So what you're going to do, remember the first column, this one here, is for x. We're going to replace these entries here, 1 and 1, with this one here, the constant, right? So we have to be very, very careful, right? So let's continue. So dx is going to be equaling to, so on the first column, remember we are calculating the determinant for x. We're going to write in the constant there, right? 9 over 2 and 2. 9 over 2 is for the first equation, and then 2 is for the second equation. So instead of writing the x coefficient, I'm going to write the constant there. But then, since we are calculating for dx, we keep the y coefficient, these ones there. We're going to write them exactly on the second column. So let's do it. So we have 3 over 2 on the first row, and we have negative 4 on the second row there. There we go. So we have our matrix there. So again, we're going to apply this method where we calculate the determinant. So just follow the first entry multiplied by the, which is 9 over 2 multiplied by negative 4, then minus, right? And then the second entry multiplied by the third entry. So we have 3 over 2 multiplied by 2. There we go. So from here, use your calculator. So this here is going to be negative 18, right? If you use a calculator. And this one is going to be minus 3. So if you put this on the calculators, they're going to give you negative 21. So dx here, it's negative 21. So I hope you guys understand this. So let's do the last one where we have to calculate the y, right? The determinant of y. Again, we're going to do the same thing that we did here or similar. We're going to take the y entries and substitute them with our constant term. So let's continue. So, but before we do that, I'd like to inform you that we have to bring back the x coefficient. So let's bring back the x coefficient on the first column. So remember it was 1 and 1. There we go. But now for the second column, because it's for y and we are calculating the determinant of y, we're going to substitute with our constant. So it's going to be 9 over 2 because 9 over 2 is from the first equation. That's why it's on the first row. And on the second row, we're going to have 2 there. That's why it's on the second row because it's a second equation. There we go. Then from there, we create our matrix then. Again, we're going to do similar thing when you calculate for dy. We're going to multiply the first entry and the last entry, which is going to be 2 multiplied by 1. 2 multiplied by 1, then minus, then open bracket, and then we multiply the second entry with the third entry, which is 9 over 2 multiplied by 1. There we go. And then from there, this is going to give us 2. It's going to give us minus 9 over 2. So if you put this on a calculator, this is going to give us negative 5 over 2. So this here is our dy. Right. Now that we managed to calculate our dy, dx, and also our d, we can calculate our x and y. Remember, we have to calculate these two unknown variables. So let's create a bit of space here so that you can able to calculate those values there. So now the formula to calculate for x and y is as follows. When you calculate for x, the formula is going to be dx over d, right? Now, what is our dx? Our dx is negative 21 divided by d. What is our d? Our d is negative 11 over 2. So whatever we're going to get here, if you use our calculator, that is going to be our x value. So I'm getting 42 over 11. So this here is our x value. Now let's calculate y. Again, similar formula. We're going to have y is equal to dy over d, right? And then what is our dy? If you still remember, our dy it's negative 5 over 2 divided by our d. Our d, just like we said here, it's negative 11 over 2. So if you continue, you put this on your calculator, y is going to be 5 over 11. Right, so these are the values for x and y there. But to double check whether our values are correct, we need to check using these equations. Remember, we have this equation and that equation there. So I'd rather take equation 2, use it to check. Equation 2, remember we have x minus 4y is equal to 2 there. So x is actually 42 over 11, right? Minus 4. And then our y, it's 5 over 11. If you put this on your calculator, this here is going to give us 2. There we go, which is the same as the 2 there. So guys, the proving or the checking is not necessary. I was just showing you guys that you can always check on your own after you have find your x and y. I hope this video helped you to understand how to calculate these unknown values, guys. So if you have a question or if you have any comment, you can leave a comment in the comment section. And if this video helped you to understand, do not forget to like, share, and also subscribe to the channel if you haven't subscribed. Again, people, I've made videos on how to calculate for x and y using Cramer's rule 2 by 2 method. So you can always go to the description. I'll leave the video there, and also the very same video will pop up on the top right of the one that you're watching at the current moment. All right, people, we are done with 2.2. Let's look at 2.3. All right, guys, here is our 2.3. Now let's look at the question here. So 2.3, they want us to convert to rectangular form. If given here, it's a complex number which is in a polar form. It has, in fact, 3 complex numbers that are in a polar form. So the nice thing about complex numbers in a polar form, they can multiply and divide. So we can able to simplify this before we convert to rectangular form. So let's start. Now, let's first change this one underneath here into a cis notation. So we can write this as 4 cis 60, the first one there, multiplied by 8 cis 100. There we go. Divide by. So this one here, guys, on the denominator, you can always write it like this as well. 2 cis 30. Okay. Cos stand for C, I stand for imaginary, and S stand for sine. Hence the word cis there. Okay. Just in case you didn't know. And this formula underneath here is a formula that we use in fact to convert from polar to rectangular, but more on that later. So since these complex numbers are multiplying each other, so 4, 8, and 2, they're gonna multiply and divide. So we can write 4 multiplied by 8 divided by 2. As for the angles, the numbers before the word cis there, they're gonna add when these complex numbers are multiplying. For example, 60 is gonna add with 100 since the complex numbers are multiplying in a polar form, and it's gonna be subtracting everything there because it's on the denominator, so it's dividing the complex numbers on the numerator. So this is actually a multiplication and division of complex numbers in a polar form. So the modulus, they will act like numbers, they will multiply and divide, and then the argument, which are the angles, they're gonna add 60 and 100 because they are multiplying those complex numbers, and then 30 is gonna subtract because it's dividing them. So if you use a calculator for the modulus, you're gonna have 16 there, and then this one after 6, you're gonna have 130. So this here, guys, is the complex number in a polar form. So we need to change it into a rectangular form or convert it into a rectangular form. So what you need to do now, you need to write it in this manner where you write modulus and then open bracket, you write cos 130 degrees, right, plus imaginary number sine 130. There we go. So this is what we have now. So all we have to do here is to use our calculators, and then we can get our values there. If you multiply 16 with cos 130, you will get the following answer here, which is going to be negative 10,285. There we go. And then if you multiply the very same 16 with sine 130, you will get plus 12,257i. So when it's like this, guys, it's a rectangular form. How do you know? There's a real number there, and it also has imaginary number. Remember, a rectangular form, when it comes to complex number, it consists of a real number and a imaginary number. Polar form consists of modulus and argument. So just in case you don't know, but I already made videos on how to convert from rectangular to polar and from polar to rectangular. I'm gonna leave a video that explains this better on the description, and also the very same video will pop up on the top right of this one that you're watching here. I hope you guys managed to understand this. Again, if you did not understand, or if you have any comment, you can comment on the comment section, and I will try to help you to my level best. And if this helped you to understand, do not forget to like, share, subscribe to the channel if you haven't subscribed. And that's it, guys. So we are done with 2.3. Let's do 2.4. Here is our 2.4. Now 2.4, we also need to solve for x. If we are given x to the power of 3 minus 8 is equaling to 0. So before we continue here, guys, this is actually the sum and the difference of two cubes. So if you don't know the formula, especially for this one, I'm gonna write it here. So basically this formula, it goes like this. If you have a to the power of 3 minus b to the power of 3, you can expand this like this. You can have a minus b, right? And then the second bracket, you square a, you add the product of a and b, and then you also add b squared, then you close the bracket. So when it's minus between a and b, the second bracket, everything is going to be positive. But don't forget to square a and square b and multiply a and b. So let's look at our equation there. So as you can see, this equation here, it has x cubed minus 8. So we can rewrite it like this. X cubed, instead of writing 8, you can write 2 to the power of 3. All right, so from here, let's expand it. So we have x minus 2, remember? And then from there, we square a. In our case, a it's x, so it's going to be x squared plus a multiplied by b. In our case, a it's x and b it's 2, so it's going to be 2 multiplied by x. So this is going to be 2x. There we go. And the last term there, we square b. In this case now, our b is 2, so 2 squared, this is going to give us 4. There we go. Then from there, we solve for x. Remember, this is equaling to 0. So let's solve for x. Now, if we solve for x, let's continue here. The first one here, the first bracket, it's fine. We're just going to drop it like this. And then the second bracket, we need to factorize it. We cannot factorize it directly. We need to use the quadratic formula. So let's do it. X is going to be equaling to negative b plus or minus square root b squared minus 4ac. All this is divided by 2a. Right. Now, remember, a is a coefficient of x squared, b is a coefficient of x, and then c, it's a constant. So let's not forget. So let's do some substitution there. So we're going to keep on dropping this one here, x minus 2, and let's start substituting on the second one. So b, we say it's a coefficient of x, which is actually 2. There we go, plus or minus. Then inside there, we have b squared, so it's going to be 2 squared minus 4. And then a, it's a coefficient of x squared, which is 1 there. And then c, it's a constant, which is 4. All this is divided by 2 multiplied by 1. There we go. So you use your calculator, but before we do that, let's continue drop x minus 2. And so if you use our calculator, we can say x is equaling to negative 2 if you remove the bracket, plus or minus, let's do this here. Inside the root, we have negative 12. There we go. Divide by 2. All right. So from here, guys, I will need you guys to pay attention, because this part here, that's where most people get confused. Let me just create a space and then let's continue. As you can see, we are dropping this x minus 2, and then let's simplify this one here. Now, remember, we are dealing with complex numbers, guys. So when we deal with complex numbers, here's what we need to do. It's going to be minus 2 plus or minus, and then here's what you're supposed to do. We can say 4 multiplied by 3, that is 12 multiplied by negative 1. And all this is divided by 2. Right, let's continue. Let's drop this x minus 2, and then let's continue there. So we're still going to have this negative 2 there, plus or minus. Now let's simplify inside the root there. We have the square root of 4. The square root of 4, we know that is 2. And then we're going to be left with 3 inside the root. We are left with the square root of negative 1. Guys, the square root of negative 1, it's imaginary number, right? So before I continue with this, just in case you don't know about imaginary numbers, I made a video on imaginary numbers. I'm going to leave a link or a video on the description. that explains the imaginary numbers. And also the very same video will pop up on the top right of this video that you're watching here, just in case you don't understand imaginary numbers, by the way. Instead of writing square root of -1, we're going to write I there for imaginary. So all of this is divided by 2. There we go. Then if you continue, we have x minus 2, right? And we can start separating now. We can say x is equaling to, now we have minus 2. Remember, we have plus or minus there. So if we say plus, it's going to be 2 root 3 divided by 2, right? Well, let's not forget imaginary there. And now x is going to be equaling to -2. This time around, guys, remember, we have plus or minus. So we're going to minus by 2 root 3i. All this is divided by 2. Okay, so let's solve for x this time. So on this one here, guys, we're going to transpose this 2 on the other side. This is going to be +2. And then these ones here, we have 2 dividing all these terms. So we're going to be actually left with -1 plus root 3i. There we go. And then the last one, which is similar to the second one, 2 dividing -2 there. So we're actually going to be left with x is equaling to -1 minus root 3i. So these ones here, guys, are your answers. So x is equaling to 2, and then x is equaling to -1 plus root 3i, and also x is equaling to -1 minus root 3i. So these two here are actually complex numbers in a rectangular form, while this one is just a real number. So I hope you guys managed to understand this. It was a bit tricky because I haven't seen a question like this before. So just in case you didn't understand it, you can leave a comment on the comment section. I'll try to answer you to my level best. But if this video helped you to understand how to solve this problem, you can always like, share, and also subscribe to the channel if you haven't subscribed. We are done with 2.4. Let's go into 2.5. All right, guys, let's look at 2.5. So this is a simplification question. So what we have here, it's imaginary numbers that has exponents. Now we need to simplify these two imaginary numbers, right? So the first thing that you must do here is to use exponents law. Now, just in case you get confused, J is the same as I. So usually we use J for electrical students, but it's the same as imaginary number. So before we start, let me inform you that J squared is equaling to -1. We need to expand these imaginary numbers. Let's start with the first one here. We have J to the power of 5. We can first expand this and say J multiplied by J to the power of 4. The aim here is to have imaginary number with an even exponent, right? If it has an odd exponent, we have to apply the exponential law, which is going to help us to have one of the J's to have the power that is even. So minus, even this one here, you say J multiplied by J to the power of 26. So these two J's here, they have the power of even number there. So the reason why we do that is because we want to use this information that we have here, right? So we can also continue and write J for the first one, but the second one, this one here, we can write it like this, J squared, then outside again we have 2. We know that 2 multiplied by 2 is going to give us the power of 4 there, right? Now minus, again we have this J there, and then this one here, we also going to say J squared, right, inside there, and outside we write 13. Just in case you don't know how to do this, guys, it's very, very simple. You write J squared, you put it inside the bracket, then this 2, you divide it there. It's going to give you this 13 here. Now let's continue. If we continue here, we're going to have this J first, and then remember, J squared is the same as -1. Remember, I showed you here. So we write -1 there, and we square it, minus, right? And we have this J there, and then this J squared is going to be -1 to the power of 13, right? So if you say -1 squared, Remember, put it inside the bracket. It's going to give you positive 1 multiplied by j. So this side, we're going to be left with j minus, right, j. And then if we say negative 1 to the power of 13 inside the bracket, it's going to give you negative 1. Then this here is going to be j minus j multiplied by negative 1. This is going to give us, so this here, guys, is our final answer for this one. Again, just in case you don't know how to simplify imaginary numbers, I made a video explaining further how to simplify imaginary numbers. We are done with question 2, guys. So if this part of the video helped you to understand how to calculate complex numbers and determinant, do not forget to like the video, subscribe to the channel, and also share the video to your friends. We'll be doing question 3 next time. All right, here's our question 3. Question 3 is based on trigonometry. So it has 5 questions. We're going to start with 3.1 and then we're going to do other questions afterwards. So let's create space so that we can do 3.1. All right, here is our question 3.1. Now, this question here, they want us to simplify as far as possible if you are given this expression here. Now, here, guys, it's when we simplify the trigonometric ratios using methods to reduce and simplify further. So, in order for you to do this problem or to solve this problem, you need to know the cast diagram when it goes forward and backward, or when it's clockwise and when it's anti-clockwise. So I'm going to write the cast diagram here on our right hand side so that we can be able to refer as we are solving this problem. So let me just write these 2 cast diagrams for the positive and the negative. All right, this is the cast diagram when we are moving in this direction here. When we are moving in a clockwise direction, the 4th quadrant, we represent it this way. It's going to be negative x in this case. We use x because we have x on our problem. So please don't forget that. Okay. And then on this one here, on the 3rd quadrant, it's going to be negative 180 plus x. That's how we present the 3rd quadrant when you go backwards. The 2nd quadrant, when you go backwards, is how we represent it. It's going to be negative 180 minus x because you're going backwards. And then the 1st quadrant, when you go backwards, it's going to be negative 360 plus x. So this is how we represent the quadrant when you go backwards. Now let's draw the cast diagram when it is positive, or when we are going on the positive side of the cast diagram. All right. So on this cast diagram, we're going to be moving on an anti-clockwise direction, or on the positive side of our angles. Now, on the 1st quadrant, when you're moving on the positive side, this is how we represent this quadrant. It's just going to be x. Remember, we're using x because our question has x there, right? Please don't forget that. But usually, we use theta on such. Our 2nd quadrant, when you go on the positive side of the cast diagram, it's 180 minus x. And then our 3rd quadrant is going to be 180 plus x. And then our 4th quadrant is 360 minus x. So these here are the cast diagram. Again, I need to add on something here because our question, it has 180 and 360. You're going to use the 180 rule. I'm going to leave a video that explains the 180 rule on the description, and also that video will pop up on the top right of this video that you're watching at the current moment that explain how to use the 180 rule. Let's start with our first trigonometric ratio on the numerator. Then we have tan x minus 180. So I would say to you, rewrite this like this: tan, right, negative 180 plus x. This here will help you to understand which quadrant exactly is this one. When it's like this, it's a bit confusing. So try to rearrange these inside them. And then you're going to continue, rewrite sine 180 plus x multiplied by cos negative x. And then on the numerator, again, there's something that we need to do here. We have sine squared 360 degrees minus x. So the problem here is the squared here. If you don't understand your math very well, you might make some mistakes. So here's what I would advise you to do whenever you come across a trigonometric ratio that is squared in such a problem. So you rather write sine 360 minus x multiplied by another sine 360 minus x. This means that if they are multiplying like this, they are squared, as you can see on the denominator of this question that we are doing here. Now that we have made our question to be easy to simplify, now let's use our cast diagrams to reduce this. Like I said, we're going to use the 180 rule. So the 180 rule, I already left the video on the description. First of all, look at your quadrant here. So what quadrant is negative 180 plus x? Since our 180 is negative, this means that we are going backwards. So we must look at the red cast diagram. So negative 180 plus x is actually on the third quadrant. So on the third quadrant is tan positive or negative. We know that tan is going to be positive. So we're going to write tan x. There we go. Plus, now we move to the other trigonometric ratio, which is 180 plus x. Now 180 plus x, this is when we are moving in a positive direction or in an anti-clockwise direction of angles. So basically, we're going to look at the blue cast diagram. Now 180 plus, when you look at the blue cast diagram, is the third quadrant. Now on the third quadrant, we know that sine is not positive. So when you reduce this, it's going to be negative sine x. There we go. Multiply by. Now we know that we have this here, which is cos negative x. So this here, for the fact that we have negative x as an angle there, it means that we are going backwards. So when you're going backwards, we'll consider the red cast diagram. Now, if you look at the red cast diagram, negative x is on the fourth quadrant. And on the fourth quadrant, we know that cos is positive. So when you reduce here, it's just going to be cos x. Please, guys, don't get confused here. And then we divide there. There we go. So as we divide here, underneath we have sine 360 minus x. So when we look at 360 minus x for both of these two trigonometric ratios, we can see that this is when we are moving in a positive direction. Now, the positive direction, we have to look at the cast diagram that is blue. As you can see, 360 minus x is actually on the fourth quadrant. Now, on the fourth quadrant, the only trigonometric ratio that is positive there, it's actually cos, and it's inverse. So meaning sine is going to be negative. So for this one, it's better to reduce this one first. If you reduce it, it's going to be negative sine x multiplied by another, this one here, negative sine x. Because if they multiply each other, this is going to give you what? Positive. That's the reason why we decided to separate them like this, right? Some of you can able to see this without separating. It's still fine. But if you're not so sure, separate. So let's create space and let's solve this further. As you continue here, now as for tan x, we're going to write it as tan x. So we're going to multiply this negative sine x with cos x. So this is going to be negative sine x multiplied by cos x. There we go. And then we divide them. As we divide, we have negative sine x multiplied by negative sine x. This is going to give us positive sine x squared or sine squared x. There we go. Now, let's continue. You can separate this. You can write tan x over sine squared x minus sine x multiplied by cos over sine squared x. This is allowed, guys, as long as this line here, it's solid. Just know that this is allowed. So let's create a little bit of space here as we continue. Now, the first one here, which is tan x divided by sine squared x, we can rewrite it like this. We can say, instead of writing tan on the numerator, we can write sine x over cos x. This is what you call the quotient identity, right? I hope you know tan is the same as sine over cos x divided by sine squared x. This sine squared x there. And then we say all this here, let's put it inside the brackets. It's minus by sine x multiplied by cos x divided by sine squared x. So as you can see, we have sine squared here divided by this sine. So what we'll be left with here, we're going to be left with cos on the numerator divided by sine. x. So for now, we're just going to leave it like this. Now, if you continue further, we have sine x divided by cos x, right? If you change this into multiplication, this division here, we know that our sine squared x is going to be dividing them. So it's going to be 1 divided by sine squared x. There we go. Remember, when you change this division into multiplication, the numerator becomes the denominator and the denominator becomes the numerator. I hope you know about this. It's a basic information. Right, so from here, we're just going to write this as it is. Cos x divided by sine x. There we go. Then from here, again, since we have multiplication here, we can say this sine and that sine can divide each other. So what basically are you left with here? You're only left with 1 over cos x multiplied by 1 over sine x. Right, let's put this inside the bracket, minus this one, we're going to write it as it is, cos x divided by sine x. I hope you guys can see. Let me create a little bit of space here because this is very, very long. All right, let's look at the first bracket then. When you look at the numerator, we have 1 multiplied by 1. So we're going to have 1 on the numerator there. On the denominator, we're going to have cos x multiplied by sine x. This is going to give us cos x multiplied by sine x minus. Now, the second term here, we know that it's going to be cos x divided by sine x. When it's like this, we need to find our LCD, which is going to be cos x multiplied by sine x. Now, we're going to divide this cos x sine x with that cos x sine x. This is going to give us 1 multiplied by that 1 there, and that is going to give us 1. Then minus that minus there. And then we're going to divide this cos x sine x with that sine x. It's going to give us cos x. Then we multiply that cos x with this cos x there. So this is going to give us cos squared x. There we go. Now, when you look at the numerator there, we have 1 minus cos squared x. So we can use this identity when we have sine squared x plus cos squared x. This is going to give you 1. We can make sine subject to the formula. As you can see here, we can say sine squared x is equal to 1. If we transpose this cos squared x to the right hand side, this is going to give us negative cos squared x. So instead of writing 1 minus cos squared x, we can substitute with sine squared x. So let's do it on the numerator then. So we're going to write sine squared x divided by cos x multiplied by sine x. So sine x and sine x there, they're going to divide each other. On the numerator, do not forget we have sine x squared. We have sine squared x, so we're going to be left with sine x there. And then on the denominator, we're only left with cos. So as you can see, we're left with sine x over cos x. This here is a quotient identity. So sine x over cos x is the same as tan x. So this here is our final answer for this question. As you can see, guys, this question here required us to know our identities, the square identities, the quotient identities, and also the cast diagram. Just in case you don't know much about this cast diagram, you can go to the description. I left the video where I talk about cast diagram, and the very same video will pop up on the top right of the video that you're watching at the current moment. So if this video helps you to understand how to simplify such questions, do not forget to like, share, subscribe to the channel if you haven't subscribed, and also comment on the comment section if you have anything to comment about. But if you didn't understand, you can always rewatch at the point where you got lost, and if that doesn't help, you can leave a comment in the comment section. All right, people, we are done with 3.1. Let's go and do 3.2. All right, people, let's look at 3.2. So 3.2, we are given the following expression there. We're given 3 cos squared x plus 11 sine x plus 1. All this is equaling to 0. So they want us to solve for x You're also given the domain here where we have negative 360 to 360. So when you look at this basically means that we have two cycles. So before we solve this, let me draw the cos diagram so that I can show you what is the meaning of all this. Now let me use different color so that you can able to see. All right, let's look at this cos diagram. I hope you can understand what is happening here, but I'll try to explain. Now I'm going to highlight the ones that are negative with blue. So from here, which is the 0 point, in this case now it's negative 360 degrees. We are moving in this direction, by the way. As we are moving in this direction, from negative 360 degrees to negative 270 degrees to negative 180 to negative 90, and then back to 0. And this is when we move from negative 360. Remember, we are moving from negative 360 to 360. Now from 0, we are moving to 90, 180, 270, and then 360. Like I said, we have two cycles. So we circulate 2 times here. Right. So let's look at our problem here. First of all, we need to simplify this so that it can become our trinomial. Now, when you look at this problem here, we have cos and also we have sine. Then we need to change one of these to be like the other, meaning we need to have the same trigonometric ratio when it's like this. Now, the one that we can able to change is cos squared x. Remember, cos squared x plus sine squared x, all this is equaling to 1. So we can make the cos squared x subject to the formula. So what can we do here? We can write cos squared x is equaling to 1. Then we transpose this sine squared x to the right hand side. It's going to become negative sine squared x. So instead of writing cos squared x, we can write 1 minus sine squared x. So let's do it. So if you look at our question, we have 3 already. So open bracket, wherever there is cos squared x, we're going to insert 1 minus sine squared x based on this one here. I hope you guys can see and understand this. Right, so let's continue. Plus 11 sine x plus 1. All this is equaling to 0. Right, so we need to remove the brackets, obviously. If you remove the brackets, we're going to have 3 minus 3 sine squared x plus 11 sine x plus 1. All this is equaling to 0. Right, so from here, we deal with the like terms. If you look at this 3 and that 1, they can add each other. So you'll be having 3 plus 1, that's going to give us 4. So if you rewrite this, it's going to give us negative 3 sine squared x plus 11 sine x plus 4. All this is equaling to 0. Then we need to change this negative to positive because our a there, it's negative. So if you multiply by negative throughout here, you're going to have positive 3 sine squared x minus 11 sine x minus 4. All this is equaling to 0. As you can see, this now is our trinomial. Now we can able to factorize this. Now we need to find the factors of 3 sine squared that when we subtract, they're going to give us negative 11. Right, and the factors of negative 4 that when we subtract, they're going to give us 11 then. So let's start. If we open the bracket, you can write 3 sine x like that. There we go. Close bracket for now. Open another bracket where we have sine x. If you multiply this 3 sine x with sine x, they're going to give us 3 sine squared x. So the factors of 3 sine squared x, we have them. Right, then let's close the bracket. We need to find the factors of 4 and insert them on these brackets so that when they subtract, they're going to give you 11. This 11 here in the middle. So let's try it. Now, if we put 1 and 4 there, right, let's see if this is going to help us, because we know that if we say 3 sine x multiplied by 4, it's going to give us 12 sine x. If you multiply these two here, it's going to give us 12 sine x. If you multiply 1 with sine x, it's going to just give us sine x. Now, since we want to have 11 here, it means that this 12 is going to be negative. So if we say 12 sine x minus sine x, that's going to give us negative 11 sine x, which is the one in the middle. So this means that this 4 is going to be negative, because if you multiply this 3 sine x with negative 4, it's going to give you negative 12x. So this is going to be positive. There we go. If it so happened that you couldn't do it this way, use the quadratic formula, guys. It's also accepted. This is going to be equaling to 0. Now let's continue with this one. It's going to be 3 sine x. All this is going to be negative 1, because if you transpose this one here to the other side, it's going to be negative. And the other one there, we have sine x, all is equaling to 4 there. Now if you continue and then we make sine survey formula, we have to divide by 3 on this one here. If we divide by 3, we're going to be left with sine x is equaling to negative 1 over 3. And then the other one, it's fine. We have sine x is equaling to 4. Right. So let's look at the one that is having negative 1 over 3 there. Now, when we have something like this, this means that our sign, it's negative. First of all, we need to highlight the quadrant where sign is negative. So what are those quadrant where sign is negative? So I'm going to highlight with green there on the cast diagram that I just created earlier. So we know that sign is negative on the third quadrant and the fourth quadrant. We are fine with that. But now we need to know, when we go backwards, how do we represent these two quadrants? We know that when you go backwards, this quadrant here is represented like this, negative 180 plus x, right? This is when you go backwards here. When we go backwards on the fourth quadrant, this here is represented by negative x. We are all good. Now let's use yellow to show when we go forward. Now when you move on the positive side, this third quadrant, this is how we represent it. It's going to be 180 plus x, right? And in the fourth quadrant, it's going to be 360 minus x. There we go. So since our sign is equaling to negative 1 over 3 on this one, we need to find the reference angle. Guys, whenever you have something like this, whenever you have a trigonometric ratio which is equaling to a negative answer, just know that you need to find the reference angle first. So let's find the reference angle. Let's zoom down so that you can have space. I hope you can still see, people. So let's focus on this one here. So when you find the reference angle, you're gonna remove this negative there and write it as if there is no negative there. So you're gonna write sine x is equaling to 1 over 3. There we go. And then we find our x. Remember, when we find our x, we're gonna transpose this sign to the right hand side and it becomes arc sine 1 over 3. So arc sine 1 over 3, it should give us a positive answer, which is going to be a reference angle. So let's use our calculators and let's insert it there. So when we insert this, it's going to give us 19.471 degrees. So here, guys, this is our reference angle. It is not the actual angle that we are looking for here. Remember, we said we're only going to focus on the third quadrant and the fourth quadrant for this one here, right? So let's do it. So on the third quadrant, can I write that here? Now we're going to have two answers here, because one, it's when we are moving in the backward direction, which is highlighted by green there, when we have x is equaling to negative 180, this one here, plus x. But our x, what is our x? Is 19.471. So x here is going to be equaling to negative 60.57 degrees. So this is one of the answers. This is when we go backwards. Now when we go forward, like this one here, still on the third quadrant, we're going to say x is equaling to 180. This time around, it's plus 19.471. And then our x here is going to be 199.47 degrees. So we have these two x's, 1 and 2. This one here is the answer for moving in a backwards direction. And this one here is the answer when we are moving in an anti-clockwise direction, which is the positive direction, right, on the third quadrant. Now, we are not done, people, because we need to do the fourth quadrant. So let's do the fourth quadrant. So when we do the fourth quadrant, remember, guys, we are only considering this one here that I highlighted in blue, guys, at the moment, right? So sign is negative there. So we have this one that is green. We said x is going to be negative there because we are moving in a backwards direction. So basically, this means that our x is going to be negative our reference angle, which is going to be 19,471. So this here is also our answer as well. This is when we are moving backwards. What is our x on the fourth quadrant? Now, when we are moving forward, you're going to consider 360 minus x. So x is going to be 360 minus 19,471. And then our final answer for this one is going to give us 340,53 degrees. So these two here are the answers on the fourth quadrant when it's going backwards and when it's going forward. I hope you guys understand this because it can be very, very tricky. And all these four answers are when sine x is equaling to -1/3. So these are the answers when our sign is negative. Now that we're done with that one, let's focus on this one here, which is sine is equaling to 4. Now, if you say, let's continue here. If you say x is equaling to arc sine 4, this here is going to give us an error. So there was no need for you to continue on this one. So these four answers, those are our answers for this question here. So I hope you guys managed to understand this. This is a bit tricky. So if you didn't understand, go to the point where you did not understand, rewatch it. And also, if that doesn't help, you can always leave a comment on the comment section. I'll try to explain to you to my level best where you got stuck. Again, I also made videos on how to solve for x using trigonometric ratios. I'm going to leave those videos on the description so that you can able to understand. And also those videos will pop up on the top right of this video that you're watching at the current moment. All right, people. But if this video helped you to understand how to solve for x using trigonometric ratios, do not forget to like, comment, share, and also subscribe to the channel if you haven't subscribed to the channel. Share this to your friends who are also doing the same subject. All right, people, we are done with 3.2. How about we continue and do 3.3? All right, guys, here's our 3.3. Now, 3.3 has two questions. So we're going to start with 3.3.1, where they want us to derive a formula for cos x over 2 if cos 2x is equaling to 2 cos squared x minus 1. They just want us to derive half angle. Let's do it. So we are given this problem here. They want us to derive half angles here for cos. So it's not really that difficult, guys. First, we are given cos 2x is equaling to 2 cos squared x minus 1. So this is what we have there. So what we have to do here is to make cos subject of the formula first. So what we can do here is to transpose this -1 to the left-hand side. So let's do it. If we transpose that -1 to the left-hand side, we're going to be having positive cos 2x plus 1 because this one's going to be positive. And then on the right-hand side, we're going to be left with 2 cos squared x. There we go. From here, we have to divide by the coefficient of cos there, which is 2. If we divide by 2 throughout here, we'll be left with the following. This 2 and that 2, they will divide each other. So on the left-hand side, we're going to be left with cos 2x plus 1 divided by 2. Let us not forget that. So on the other side here, we're going to be left with cos squared x. There we go. Then from here, we can square root to remove the square there. Let's square root both sides. So if you square root there and also square root on the left-hand side, this square and the square root, they will give you 1 as the power. And then on the left hand side, you're going to be left with the square root of, let me just continue here, cos 2x plus 1 divided by 2. All this is equaling to cos x. Right. So I'm going to continue here on top. What we need to do here, remember, we are being asked to have half angle. We are being asked to have cos x over 2, which is the half angle. As you can see, we have this one here. It has only x. So what we need to do here, we need to divide this angle by 2. What you do on the left hand side, you must also do on the right hand side. So also here, this angle, you must also divide by 2 there. So if we divide these angles, let me continue here, guys. We're going to have the square root. 2 divided by 2. As for the angles, we're going to be left with only cos x there plus 1. All this is divided by 2. That 2 there, please don't forget. And then all this is going to be equaling to, so this is going to be cos x over 2. As you can see, this is what they were looking for. Please be careful. This 2 is only dividing the angle, which in this case, it's only x. So this is basically what they are looking for. They wanted us to derive this formula here. I hope you guys understood how to derive this formula. I've left a video on how to derive half angle in terms of sine and cos. So go and watch that video in the description, and the very same video will pop up on the top right of the one that you're watching at the current moment. Go and watch it just in case you didn't really understand how to do this. But if you managed to understand how I've done this one here, please do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed to the channel. Then if you didn't understand, again, you can always leave a comment in the comment section. I'll try to explain to you to my level best. Right, people, we are done with 3.3.1. Let's look at 3.3.2. All right, people, let's look at 3.3.2. Now, the question on 3.3.2, it goes like this. Use the formula derived in 3.3.1 to determine the exact value of cos 15 degrees without using a calculator. So what they want from this question, guys, is for us to use the equation that we derive on 3.3.1, which is the one that I left here. Use it to calculate cos 15 degrees without using a calculator. So this is how you're supposed to do it, people. Remember, we have cos 15 there. So we know that we can write cos 15 degrees as cos 30 degrees divided by 2. Wherever there is x, we can put 30 there. So let's do it. So we can say cos 30 degrees plus 1 divided by 2. And then here we can say cos 30 degrees divided by 2. So from here, you need to use the special angle triangles. So let me just write the special angle triangles on the side here. I'm just going to use the one that is required. All right, so here's our special angles. Obviously, we have another triangle that is special angles, but this is the one that we're going to use. Again, just in case you don't know much about these special angles, I've done a video on these special angles. Go to the description. I'm going to leave a video where it talks about these special angles. And also the very same video you pop up on the top right of this video that you're watching at the current moment. Right, so let's continue. Let me first zoom down. All right, so let's look at our triangle then. We have cos 30 there. Guys, cos 30, we know that cos is adjacent over hypotenuse. Now, when you look at 30, here's our 30 here. Our adjacent is root 3. And then our hypotenuse is 2. So we can write this here. We can write as root 3 over 2 plus 1. All of this is divided by 2. Remember, that is cos 30. Cos 30, guys, when you look at this triangle, is the same as root 3 over 2. There we go. Now we can continue from here. Cos 30 degrees divided by 2. We can continue here, people. Let's create a bit of space again. Now, if you continue, we still have the root there, guys. Still have the root. We can say root 3 over 2, right? Plus 1 over 1. All this divided by 2. The 2 there, guys. Just decided to write it like this. So we have to find the common denominator on the first bracket. So let's find it. LCD. We're going to have 2 there. So we know that 2 into 2 is 1 multiplied by root 3. This is going to give us root 3. There we go. Plus 1 into 2, it's 2 multiplied by 2. That is going to give us 2. Instead of writing this division here, we can write as multiplication. If you write as multiplication, it means that now they're going to swap. You're going to have 1 over 2. 2 is going to become a denominator and 1 becomes a numerator. So let's continue. Let us not forget this is equaling to cos 80 degrees divided by 2. Both of them, they're still equaling to cos 80 degrees over 2. There we go. So from here, we're going to continue and put this under the root. On the numerator, we have root 3 plus 2 multiplied by 1. That is going to give us root 3 plus 2 divided by. On the denominator, we have 2 multiplied by 2. This is going to give us 4. All this is equaling to cos 80 divided by 2. Right. So if you look at this, we can say the square root of 4, which is our denominator, is going to be 2. So we can write this answer like this. We can say root and then root 3 plus 2. All this is divided by 2. And this is equal to cos. What is 30 divided by 2? It's going to be 15. So this is our final answer, guys. Don't go further than this. If you go further than this, it's going to give you a decimal answer. So we rather leave it like this. Besides, it was out of 6 marks. Guys, this question here, it was not as difficult as it seemed. But if you didn't understand your special angles, you didn't understand your half angles, then this was going to be a bit challenging. But guys, this is how you do this. So just in case you didn't understand, please do not forget to rewatch at the point where you got lost. If that doesn't help, you can leave a comment in the comment section. I'll try to help you to my level best. But if this video helped you to understand how to solve such problems, do not forget to like, share, also comment as well, and also subscribe to the channel if you haven't subscribed to the channel. All right, people, we are done with question 3. I hope you managed to get it. We will be doing question 4. All right, guys, here is our question 4. So as you can see, this question 4 has 5 questions and it is based on differentiation. So we're going to be doing this question 4.1. So we need to create a little bit of space there before we do question 4.1. Okay, guys, here's our 4.1. So 4.1, they want us to differentiate y is equaling to 2x to the power of 3 minus 4 using the first principle. So we're going to derive using the first principle. So before you do that, you need to know the formula for the first principle. Let me just write the formula very quickly so that we can able to solve this problem. So it goes like this. F of x prime is equaling to limit h approaches 0. And then you have your f of x plus h minus f of x. All this is divided by h. You need to find your f of x plus h and substitute it there. And also you must substitute f of x. So what we have here is f of x. Let me show you what is our f of x. So our f of x is this one here, is given to us. So we are fine with f of x. So we can say our f of x is actually, the question there is 2x cubed minus 4. That is our f of x. So what we need to find here is our f of x plus h. So f of x plus h is equaling to 2. So wherever there is x, we have to substitute with x plus h. So x plus h to the power of 3. Let's not forget this x has the power of 3 there. Minus 4. There we go. So this is how we're going to find our f of x plus h. But we are not done here. We need to factorize this part here, which is open bracket x plus h close bracket to the power of 3. So we need to factorize it. In order for us to factorize it, we need to use the binomial theorem. So let's continue. f of x plus h is going to be equaling to 2. So instead of substituting immediately, how about you write the formula of binomial theorem? So the formula goes like this. We have x to the power of n, the first term, plus n x to the power of n minus 1 multiplied by h. That is the second term. And the third term is going to be n multiplied by n minus 1. All this divided by 2 factorial. Let me write it, 2 factorial multiplied by x to the power of n minus 2 multiplied by h squared. Close bracket minus 4. So let me just highlight very quickly. So this part here is the one that needed us to use the binomial theorem. So this is actually the part here. There we go. So I'm just going to highlight as we continue so that you don't get lost when I'm substituting the values there. Before we continue, I'd like to let you know, guys, I've already done videos on binomial theorem. Just in case you don't know this formula, you can go to the description and click on the link of that video. Watch it in order for you to understand how the binomial theorem works and how to apply it. And the very same video will pop up on the top right of the one that you're watching at the current moment. Click on that icon and you can able to watch the video based on binomial theorem. So let's continue. When we continue here, we still have 2 outside the bracket. Then inside the bracket, we have x to the power of n. So the x inside the bracket here, it's actually x. So you're going to write x there. But n, it's actually 3 there. The exponent of 3, that is our n. So we're going to write to the power of 3 there. Now we are done with the first term. Now let's do the second term. The second term, we have n. We already established that n is equaling to 3. And we have x to the power of n minus 1. So this is going to be 3 minus 1. So you can write as it 2. And then we have multiplied by h. What is h? H is actually h there. So you just write h there plus. So the third term, we have n, which is 3 there, open bracket. We have n minus 1. Remember, 3 minus 1, this is going to give us 2. All this is divided by 2 factorial. There we go. And then we have x to the power of n minus 2, which is going to be 3 minus 2 as exponent. This is going to give us 1. Even if you don't write anything there, it's fine. Multiplied by h squared. Close bracket minus 4. I know that some of you have to expand this to the fourth term. Yes, we expand this to the fourth term when they ask us to expand the expression. But here we are deriving using the first principle. So it's fine, people. You can leave it on the third term so that you can save time. If you're not comfortable in expanding this to third term, you can expand it to fourth term. It's also fine. You're going to get the correct answer. But I would advise you, especially on this type of a question, to expand your binomial theorem to only third term. So let's continue. If we continue, we still have 2 there. Now let's simplify what is inside the bracket then. Let me first highlight this. Remember, this is inside the bracket. We expanded this, guys. Do not forget. After opening the bracket, we're going to drop this x cubed. And also the second term, we're going to write it as it is. We have plus. Now, the third term, we need to be very, very careful. We have 2 multiplied by 3 on the numerator divided by 2 factorial. This here is going to give us 3x multiplied by h to the power of 2, close bracket, minus 4. There we go. So we already simplified this one here. Let me highlight so that you can keep track that this is our x plus h to the power of 3. But let's continue. As we continue here, let me get rid of the bracket. So let me create a bit of space here. Let's get rid of the bracket. If you multiply these 2 with x cubed, we're going to have 2x cubed. If you multiply this 2 with this one here, which is 3x squared multiplied by h, this is going to give us plus 6x squared h. If you multiply the very same 2 with another 3x h squared, this is going to give us plus 6x h squared minus 4, the 4 that we had there. So this here is our f of x plus h. There we go. Now that we find our f of x plus h, we can start substituting our values there on our formula. So let's go to the equation. Here's our equation here. So we're going to substitute our f of x plus h there and f of x there. So where are they? This is our f of x, and this here is our f of x plus h. So let's start substituting. All right, we're going to continue here on the right. So we have f of x prime is equaling to limit h approaches 0. There we go. So we have to substitute our f of x plus h and f of x. So here's our f of x plus h here. So we have to write all of it there. It's going to be 2x cubed plus 6x squared h plus 6x h squared minus 4. So this is our f of x plus h. Let's not forget it is minus by f of x. So here's our f of x, the question or the equation that is given to us on the statement. So let's not forget we have minus there. Here's our minus there, guys, just in case you don't understand. So make sure that you put it inside the bracket. As you can see, I have opened the bracket here. So you're going to put your f of x inside the bracket, which is going to be 2x cubed minus 4. Guys, do not forget to put it inside the bracket. It's very important. All this is divided by h. If you continue like this, we're going to have f of x prime, which is equaling to limit h approaches 0. Unfortunately, for f of x plus h, we're not going to do anything. We're going to write it as it is. We're going to have 2x cubed plus 6x squared h plus 6x h squared minus 4. We're going to get rid of this bracket and multiply by this -1 here before the bracket. So if you multiply -1 with 2x cubed, this is going to be minus 2x cubed. And we multiply this -1 with -4, that is going to give us positive 4. There we go. And then we divide by h. Now that we are here, we need to find the like terms. So let me highlight the like terms. Right, let's start with the first term. We have 2x cubed, which is positive. I'm going to highlight it with red. Here it is there. With another negative 2x cubed, this one here. They're going to cancel each other, that's for sure. We also have -4 and positive 4. They will have to cancel each other. So let's do it. This and that will cancel each other. -4 and positive 4 will also cancel each other. So what we left here with is going to be 6x squared h and 6x h squared. So let's write f of x prime is equaling to limit h approaches 0. So we left with what here? We left with 6x squared h plus 6x h squared. All this is divided by h. Guys, to check whether you did the right thing on this step that we are currently in, you must be only left with terms that contains h. If it so happens that you have a term that does not contain h, you have made a mistake somewhere. Go and double check, especially here. Probably forgot to put the brackets there. So let's continue. As you can see on the numerator, we have two terms and both of them, they contain h. So it means we have the common factor. So if you continue, we have prime f of x is equaling to limit h approaches 0. If you take out the common factor on the numerator, we're going to have h. On the first term, we're going to be left with 6x squared plus 6x h. There we go. All this is divided by h. Right. Now, this h here on the denominator and that h there on the numerator, they will divide each other. So what you're left with here is going to be f of x prime limit h approaches 0. Going to be left with 6x squared plus 6xh. Let me just create a little bit of space so that we can able to answer this. So from here, guys, we have to substitute h with 0 because our h is approaching 0. So let's continue. We have f of x prime, which is going to be equaling to 6x squared plus 6x. Wherever there is h, is going to be 0. Remember, h approaches 0. And whenever you do this step, you lose this here limit and h approaching 0. There we go. So our final answer, our f of x prime, is going to give us 6x squared. So this how you're supposed to do this question. Guys, this question, it was not that difficult. It was actually simple and straightforward. But I would understand if you didn't manage to get this because of the binomial theorem. If this video helped you to understand how to solve this type of a question, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed to the channel. But if you didn't understand, you can always leave a comment on the comment section and I'll try to help you to my level best. But we are done with this question, which is 4.1. We're going to do 4.2. All right, guys, here is our 4.2, right? So let's read the question. It goes like this. Differentiate y is equal to 3x squared multiplied by pi to the power of x using the product rule. So here we're gonna differentiate this expression here using the product rule. Now the product rule, it has a formula, guys. Again, let me write the formula for product rule. It goes like this. When we have y equaling to f of x multiplied by g of x, your answer, your dy over dx is gonna be f of x prime multiplied by g of x plus f of x multiplied by g of x prime. So basically what you're doing here, you derive the first one and you leave the other on the first term. And the second term, you derive the other one and you leave the first one. So basically that's what's happening there. So with this equation here, let me just write it here. We have y is equal to 3x squared multiplied by pi to the power of x. We have two functions there that are multiplying each other. So that's the reason why we call it the product rule, because of that. So we can call the first one here f of x, right, multiplied by the second one here. Let's call it g of x. There we go. What you need to do here, the best thing that you can do is to derive these separately. So remember I said f of x, in this case here, we say is equal to 3x squared. Now you have to derive this f of x prime. What is it? So we're going to use the standard derivative where we're going to have 6x there. Just in case you don't know about the standard derivative, there is a video that is based on the standard derivative. I will leave it on the description, and also the very same video will pop up on the top right of the one that you're watching at the current moment. Now let's do the other one, which is g of x. So g of x, we said is equal to pi to the power of x. So when you derive g of x, before you derive it, this is an exponential derivative because x is the exponent there. G of x prime is going to be the following. Pi to the power of x multiplied by ln pi. Right. So this is a derivative of the exponential function. Just in case, again, you don't know much about exponential derivative, I will leave a video on the description. Go and click on that video on the description. And the very same video will pop up on the top right of the one that you're watching at the current moment. So you can click on the icon on the top right there to watch and understand the exponential derivative. Now that we managed to derive f of x and g of x, it's time for us to use this formula here. So we can say dy over dx is as follows. Remember, we first derive our f of x. If you can see, the derivative of f of x is actually 6x multiplied by g of x. So our g of x is actually this one here, pi to the power of x. So multiplied by pi to the power of x. Then what do we do here? We add, right? Plus. Then what do we do? We write our f of x. Here's our f of x there, which is 3x squared, right? And then we multiply by g of x prime. Our g of x prime is this one here, which is going to be multiplied by pi to the power of x ln pi. So here, guys, it's our final answer. Just in case you got confused somewhere, just watch at the point where you got confused. If that doesn't help, leave a comment. I'll try to help you to my level best. But this was not difficult at all. If you don't know the product rule, again, there is a video of product rule I've made already. You can go to the description, click on that video, and also the very same video will pop up on the top right of the video that you're watching at the current moment. Go and watch that video to learn about the product rule. So this is how you derive this equation here using product rule. I hope you guys managed to understand this. So if this video helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. Right, people, we are done with 4.2. Let's go and do 4.3. All right, people, let's look at 4.3. Now, 4.3, it goes like this. Determine y limit x approaches 3, open bracket. In the numerator, we have x squared minus 9 divided by, on the denominator, we have 3x minus 9, close bracket. So they want us to find the limit of this problem here. So let me rewrite it here so that we can able to see it clearly. We have y, right? And then they say limit x approaches 3. Open bracket, we have x squared minus 9 on the numerator. And then we have 3x minus 9, close bracket. So they want us to find the limit of this expression. Yeah. So when you do limits, guys, you have to do the first step. So the first step, you need to do direct substitution. So since x is approaching 3, wherever there is x, we're going to substitute with 3. So let's do it. So I'm just going to do it here. On the numerator, we have 3 squared. Remember, x is approaching 3. Wherever there is x, we substitute with 3. Minus 9. Divide by 3 multiplied by 3 minus 9. There we go. If you continue here, we're going to have on the numerator 9 minus 9. That is going to give us 0. On the denominator, we also have 9 minus 9. That is going to give us 0. So when it's like this, this is actually infinity. We need to do the second step. Now, the second step, guys, is to do simplification. Can we simplify this expression here? When I look at it, yes, we can. So let's do it. Y limit x approaches 3. Let me just say equaling to them. Now, if you look at the numerator there, we have the difference of 2 squares, guys. So the difference of 2 squares is going to be x minus 3 and x plus 3 when you factorize it. And then underneath there, we have the common factor, which is 3. If you take out 3 as a common factor, we're going to be left with x on the first term minus 3 there. Now, if you can look there, we have x minus 3 and another x minus 3 there. So what we are left with here, we are left with y limit x approaches 3. And then we only left with x plus 3 divided by 3. That 3 there. There we go. So when it's like this, we can do direct substitution. So let me do it then. Wherever there is x, I'm going to substitute with 3. We have 3 plus 3 divided by 3. So 3 plus 3, it's going to give us 6. Divided by 3, that is going to give us 2. So guys, this is our limit. Our limit is actually 2. Guys, just in case you don't know how to do this limit, again, I've done the videos on limits. Go to the description. When I leave a video that is based on limits, on the description, click on that video. And also the very same video will pop up on the top right of the one that you're watching at the current moment. Go and watch those videos in order for you to understand limits. All right, people, we are done with this. If you didn't understand this question, please rewatch at the point where you didn't understand. Again, if this doesn't help, you can leave a comment in the comment section. But if this helped you to understand how to solve such problem, don't forget to like, share, comment, and also subscribe to the channel. Since we are done with this, let's go and do 4.4. All right, guys, let's look at 4.4. They want us to differentiate this expression here with respect to x. So let me rewrite it so that we can able to simplify it. So we have y is equaling to open bracket and another inner open bracket, x to the power of -1 plus x close bracket squared open bracket multiplied by root x. So this is what they want us to differentiate. As you can see, this here, it needs us to simplify it further before we differentiate. Guys, you cannot differentiate with this type of expression like this. You need to simplify it further. So let's start. Y is going to be equaling to open bracket, the outer one, and then we also have to do this one inside there. So write this x to the power of -1 as 1 over x plus x, close bracket, and then open bracket. Remember, we have squared there, so let's repeat it. It's going to be 1 over x plus x, close bracket, we close the bigger bracket. Instead of writing the square root of x, we can write x to the power of half. It's very important for you to change this as well. Let's continue. Now, we're going to open the bracket. So we're also going to open the ones here. You have to do FOIL. If you multiply 1 over x with 1 over x, you're going to get the following: 1 over x squared. If you multiply 1 over x with x, you're actually going to get plus 1. There we go. Then we come to this one. You're going to get another 1. There we go. And then when you multiply x multiplied by x, you will be getting x squared, close bracket. Then this one here, we have x to the power of half. There we go. Then from here, we have to simplify the ones inside the bracket. So let's continue. As you can see there, open bracket, we have like terms. We have 1 and 1. So 1 and 1, they're going to give you 2. So we can write this as 1 over x squared plus 1 is going to be 2 plus x squared. There we go. Multiplied by x to the power of half. Again, we are not done. We need to get rid of this here. Before we get rid of the brackets, we need to rearrange this. We can write the first term here as x to the power of negative 2 plus x squared. All this multiplied by x to the power of half. So let's get rid of the brackets. So if we get rid of the bracket, we're going to multiply this x to the power of negative 2 with x to the power of half. Guys, we have to use the exponent laws here. When you multiply x to the power of negative 2 with x to the power of half, since the bases are the same, the exponent will add. So basically, here's what's going to happen. It's going to be x to the power of negative 2 plus half. So this is going to give us x to the power of negative 3 over 2. There we go. We continue. We multiply this 2 with that x to the power of 1 over 2. This is going to give us 2x to the power of 1 over 2. And then we do the last term here. We have x squared multiplied by x to the power of 1 over 2. Again, let's do it here. X squared multiplied by x to the power of 1 over 2. Remember, the bases are the same. The exponent must add. So we have x to the power of 2 plus half. So this here is going to give us x to the power of 5 over 2. So we're going to write x to the power of 5 over 2. All right, so before you continue, some of you are confused. How do I get to this point here? These are exponents law, guys. Just in case you don't know much about exponents law, there is a video where I explain all these exponents law. I'm going to leave that video on the description, and also the very same video will pop up on the top right of the one that you're watching. All right, people, let's continue. So when it's like this, we can able to derive. So I'm going to do it here on top. dy over dx. All this term, you're going to use the standard derivative. So if you still remember, the standard derivative goes like this. Y is equaling to x to the power of n. If you derive this, dy over dx is going to be n x to the power of n minus 1. So that's what you need to do. Let's start with the first term. There we have x to the power of negative 3 over 2. So we have to first multiply by that negative 3 over 2. And then we have x to the power of negative 3 over 2 minus 1. That's the first term there. Plus. And then we have the second term. We have 2x to the power of half. So here we have to multiply by 1 over 2 inside the bracket, which is our exponent, multiplied by 2x to the power of half minus 1. So it's going to be half minus 1. There we go. And then the last term, we have x to the power of 5 over 2. So we're going to multiply by 5 over 2. And then we have x to the power of 5 over 2 minus 1. So let's simplify this further. dy over dx. This here is going to give us negative 3x. What is the power when you have negative 3 over 2 minus 1? This here is going to give us negative 5 over 2. All this is divided by 2. And then we continue here. Plus, we have this 2 and that 2. They will divide each other. So we're going to be left with x. What is the power of half minus 1? It's going to give us negative 1 over 2 as the exponent. Plus, now we have 5 multiplied by x to the power of 5 over 2 minus 1. This here is going to give us 3 over 2 as the exponent. All this divided by 2. Right. So this is our answer, but never leave your answer with negative exponents. So let's change our exponents to positive. So dy over dx is going to be negative 3 divided by 2. Since we changed the exponent, which is negative 5 over 2, we can make it to be x to the power of positive half over 2. Remember, if our exponent becomes positive, the base, which is x, is going to be on the denominator. Right, so let's continue. The second term here, we have x to the power of half. We can write 1 over x to the power of positive half. There we go. And the last time we changed nothing there because our exponent is positive. So we're going to have 5x to the power of 3 over 2 divided by 2. There we go. You can go further. By the way, this is the answer. But if you decide to go further and leave the answer in SATs, you can write the following. Negative 3 over 2 multiplied by root x to the power of 5 plus 1 over root x plus 5 over 2 root x to the power of 3. So you can leave your answer like this. It's still fine, people, but this one as well, it's accepted. Guys, if it's what happened that you didn't understand how to do this question, please do not forget to watch at the point where you got lost. And if that doesn't help, people, leave a comment in the comment section. I'll try to help you to my level best. But if this video helped you to understand how to solve such problems, you can like the video, share the video, comment on the video, and also subscribe to the channel if you haven't subscribed to the channel. All right, people, we are done with 4.4. Let's go into 4.5, which is the last question of question 4. All right, guys, here's our 4.5. Now, 4.5, we are given this expression here, or the function. We have f of x, which is equaling to x cubed minus 2x squared minus 8x. Now, they want us to calculate, using differentiation, the coordinates of the turning point and the point of inflection, and also distinguish between the maximum and the minimum turning point by using the second derivative. So this question here, they want us to find the turning point first, point of inflection, and distinguish between maximum and minimum turning point using the second derivative. Right, so whenever they ask you to find the turning point, guys, you first have to derive this equation once and equate it to 0. So let's do it. So if you say f of x prime, it's going to give us, the first term is going to be 3x squared minus 4x minus 8. So this here is the first derivative, and it's going to be equaling to 0. So when it's like this, guys, this means that you need to solve for x. So when you solve for x, unfortunately for this one, we need to use the quadratic formula. So let's do it. So it goes like this. X is going to be equaling to negative b plus or minus square root of b squared minus 4ac divided by 2a. Right, so this is what we have there. Now, for those who don't know, in a trinomial, we have the coefficient, which is going to be a. In this case now, it's our 3. And then the coefficient of x is going to be negative 4. And the constant there, which is going to be negative 8. Right, so we have to substitute those coefficient and the constant in our equation there. So let's do it. We have x, which is going to be equal to negative b, but in our case, negative b is going to be negative 4. There we go. Plus or minus, and then we put it inside the square root there. So that is going to be negative 4 squared minus 4 multiplied by a, our a, which is 3 there, multiplied by c, our c, which is negative 8. And then all this is divided by 2a, but a is 3. There we go. So from here, we can use a calculator. Let's start with the first one here, negative and negative. This one is going to give us 4 plus or minus. So let's write our root here. So what we have inside the root there is going to be 112 divided by 6. So let's write 6 here. Let's continue here on the top right. We know that we can write it like this. X is equaling to 4. Remember, we have plus or minus there. We can start by saying plus, and then we have the root of 112 divided by 6. And x is equaling to 4 minus, instead of positive this time around, square root of 112 divided by 6. There we go. Now, if you put this on a calculator, what I'm getting there is 2,431. And the other x is going to be equaling to negative 1,1. So these are our x's when we use this equation there, or when you solve for x equation here. So we need to find the y coordinate of the turning point. So we can continue here and say when x is equaling to 4,31, what is our y? There we go. What is our y? What you're going to do to find y, we need to use our original equation there from the statement. Wherever there is x, we're going to substitute with 2,431. So let's do it. So we have x cubed. Instead of writing s cubed, we're going to write 2,431 cubed minus 2x squared. Instead of writing s squared, we're going to write 2,431 squared minus 8x. Instead of writing x, we're going to write 2,431. There we go. Put this on a calculator, then we find our y value. So what is our y value? It's going to be negative 16,9. Right. So we already find the value of y when x is equaling to 2,431. So we can call this one turning point 1. Let's call it TP1. So x is going to be 2,431. Y is negative 16,9. There we go. So this is our turning point 1 when x is 2,431. But when x is equaling to negative 1,1, what is our y? There we go. So very simple. We're going to do similar thing that we did on the first turning point. We're going to use the original equation. We know that y is going to be equaling to, instead of writing x, we're going to write negative 1,1 cubed there minus 2. Negative 1,1 squared minus 8 multiplied by negative 1,1. There we go. Put this on a calculator and then you get the following. Let me first create a space. Y is going to be equaling to 5,049. So turning point 2, when x is negative 1,1, or y is going to be 5,049. There we go. Now we already find the turning point of this. It's time for us to distinguish which one is maximum, which one is minimum between these two turning points. Now, I need you to listen very, very careful, guys. When you try to find, or when you try to distinguish which one is the maximum and which one is the minimum, you need to derive twice and substitute the x value of the turning point. So you need to derive twice and then substitute these values here on that second derivative. And then when your answer it's greater than 0, just know it's a minimum turning point. And then if the answer is less than 0, just know it's a maximum turning point. So let's do it. The second derivative is d squared y over dx squared. Remember, the first derivative we had 3x squared, so this is going to be 6x minus 4. There we go. So what you're going to do here, we're going to substitute our turning point. Again, when x is equaling to 2,431, let's substitute them. So d squared y over dx squared. So wherever there is x, we're going to substitute with 2,431. So let's do it. We have 6, 2,431, close bracket, minus 4. What do you get there? I am getting 10,586. So this is greater than 0. So it makes this one to be minimum. So you can write this turning point here, it's minimum turning point. Now it's time for us to find the maximum turning point. So we're going to do the same thing that we did here. We're going to substitute the x value on our second derivative there. So let's do it. So d squared y over dx squared when x is equaling to negative 1,1. This one here, guys, just in case you didn't understand. So it's going to be equaling to 6. Instead of writing the x there, we're going to write negative 1 comma 1 minus 4 there. And then our answer is going to be negative 10 comma 6. As you can see, it is less than 0. This makes it to be maximum turning point. So you can write here maximum turning point. So this is how you distinguish between the maximum and the minimum turning point. I hope you managed to understand this. Now we have the last question there, which they want us to find the point of inflation. So let's find the point of inflation. Now, let me create a bit of space here so that you can be able to find the point of inflation. Guys, when you find the point of inflation, your second derivative must be equaling to 0. If you still remember, our second derivative, d squared y divided by dx squared, was equaling to 6x minus 4. But then this must be equaling to 0. And then you start solving for x. Usually when you calculate for a point of inflation, the second derivative must be equaling to 0. So in order for us to solve for x, we need to transpose this negative 4 to the right hand side. We're going to be left with 6x is equaling to 4. And then we divide by 6 there, we divide by 6 there. So x is actually equaling to 2 over 3 or 0.667. So this is our x coordinate for the point of inflation. Now, the y coordinate, we're still going to have to take the original equation. Our original equation, we have y is equaling to x cubed minus 2x squared minus 8x. So this is our original equation. So in order for us to find the y coordinate of the point of inflation, we substitute by our x coordinate there. So let's do it. So wherever there is x, we're going to substitute with 2 over 3, and then we put cube there, minus 2, and then we have 2 over 3, and then we have squared there, minus 8, and then we also have 2 over 3. If you put this on your calculator, we're going to get negative 5.926. So this here is our y coordinate. So point of inflation, the coordinate go like this. We have 2 over 3 for x, and for y we have negative 5.926. There we go. So here is everything on that question. So guys, this is how you do this problem here. Let me try to zoom down. Maybe you can able to see all the problems, but it was not that difficult, people. This is actually straightforward. All you have to do is to find the turning points by differentiating once for x coordinate and substitute those x coordinates on the original equation. You get the y coordinate, and then you check or you distinguish between the maximum and the minimum by the second derivative and substitute the x values. And when you get the negative answer, just know it's a maximum, and when you get the positive answer, just know it's a minimum turning point. As for the point of inflation, you derive twice and you equate that derivative with 0. You solve for x, you get the x coordinate. Take the very same x coordinate, you substitute on the original, you get the y coordinate. So that will be the coordinate of the point of inflation on this question. Guys, if it so happened that you didn't understand this question, please do not forget to leave the comment on the comment section. But before you do that, watch the video at the point when you get lost. And if that doesn't help, that's when you can leave a comment. But if this part of the video helped you to understand this type of a question, do not forget to like, share, comment, subscribe to the channel if you haven't subscribed. Guys, we are done with question 4. We'll be doing question 5. All right, guys, here's our question 5. Now, question 5, it is based on integration. So as you can see here, it has about 4 questions with sub-questions in there. So we're going to start with 5.1, which is this one here. And then we're going to create a space and solve it. So let's go to 5.1 and let's solve it. All right, here is our question 5.1. Now let's read the question and let's solve this problem here. Integrate the following with respect to x. Now this is a polynomial. They want us to integrate each and every term of this polynomial. So if I count here, we have 1, 2, 3, 4, 5, 6, 7 terms. So we need to integrate all these terms. So before we do that though, we need to simplify some of the terms before we integrate. So I'm going to rewrite this question and simplify the terms that need to be simplified. So when you are simplifying, you also need to keep the sigma there, open bracket. So the first term we have 4 multiplied by 5 to the power of 3x. So 5 to the power of 3x. It is simplified. We can integrate this. Let's do the second term. So the second term, there's no simplification required there. We have 4 cos 4x. No simplification required there. And then we go to the third term. We have 7 sec squared. Also, there's no simplification required there. 7 sec squared x. Let's go to the fourth term. Now we have minus. We can say pi over 2x multiplied by 1 over x. Right, decided to separate them. This is the same as pi over 2x there, but decided to separate 1 over x with pi over 2. Then we add them. The fifth term, we have sine 6x. No simplification required. The sixth term, we have negative 2 over 3, but we have root of x cubed. So we can write this term like this, open bracket, x cubed. Instead of writing the root, we can write in terms of exponents. We have 1 over 2, the power there, then minus. The last term there, it's also fine, no simplification required. We can say 1 over 2 multiplied by cosec 2x multiplied by cot 2x, close bracket, dx. Right. Again, we still have to simplify this term here because of these exponents there. As for other terms, they are already simplified. So since we are simplifying that term there, we need to rewrite all other terms there. So let's continue. We have sigma, open bracket, 4 multiplied by 5 to the power of 3x plus 4 cos 4x plus 7 sec squared x minus pi over 2 multiplied by 1 over x plus sine 6x minus 2 over 3. Now, let's look at x there. We have x to the power of 3 multiplied by 1 over 2. So we can say x to the power of 3 over 2. There we go. Minus 1 over 2 cosec 2x multiplied by cot 2x, close bracket, dx. Right, so when it's like this, now we can able to integrate each and every term that you see here. Now the next step here is to recognize the functions and know which integrals are they. Now let's start with the first term, where 4 multiplied by 5 to the power of 3x. Since we have x as an exponent, this here is an exponential integral. So when you integrate this, we can say y is equal to, we have the coefficient, which is 4 multiplied by our base, which is 5, and exponent 3x there. But this time around, we have to divide by the coefficient of x, which is 3 there, and also that 3 we multiply with natural log base, which is 5 there. There we go. Again, guys, this is an exponential integral. Just in case you don't know much about exponential integral, you can go to our description and click on the video where I explain this type of integral. And the very same video will pop up on the top right of the video that you're watching at the current moment. Now let's go to the second term. Now the second term, we need to integrate 4 cos 4x. Now first we have to add the coefficient there, which is 4. And then we integrate cos. So the integral of cos, we know that it's going to be positive sine 4x. And then since we have the coefficient of x there, it's going to be divided by 4. Again, people, this term here is a trigonometric ratio. So meaning this is a trigonometric integral. Again, if you want to learn about trigonometric integrals, I left the video there. You can go to the description and watch the video based on trigonometric integration. Right, let's move to the third term. We have 7 sec squared x. Now, this one here, guys, is very, very tricky if you don't understand. But we know that 7 is our coefficient. We need to integrate sec squared x. Now, remember, integration is the opposite of differentiation. When you differentiate tan, you'll get sec squared x, meaning that the integral of sec squared x is actually tan x. Right, so let's write tan x. Right, so let's go to this term here, which is our fourth term. We have minus pi over 2 multiplied by 1 over x. So this one here is actually the integral of log. Some of you may wonder, how do you see it? We have 1 over x here. This here, guys, is integral of natural log. As for pi over 2, These here are just coefficients. So we're going to continue, right? Negative pi over 2 multiplied by ln x. There we go. I hope you guys know this. It's really, really simple. Again, if you don't understand it, you can go to our description, go and watch a video based on this type of integration, which is a log integral. Again, the very same video will pop up on the top right of the one that you're watching at the current moment. Now let's go to the fifth term, which is sine 6x. So before we solve this is a trigonometric integral. So we know that this is going to be plus, but then we need to integrate sine. The integral of sine, we know that it's going to be negative cos. Now instead of writing s, we're going to write 6x, and then we're going to divide by the coefficient of x, which is what here? Which is 6. There we go. And then we do the sixth term here. All right, before we go to the sixth term, let me create a space because it's really going to need us to have space here. It's going to be minus 2 over 3. Then we have x to the power of 3 over 2. Remember, this is the standard integral, so you must add plus 1 there. And in the very same 3 over 2 plus 1, you have to divide by it. So we can divide by 3 over 2 plus 1. Here we go. Then before we do the last integral, this is a standard integral, guys. If you don't know how to do the standard integral, you can always, guys, go to the description. I will leave the video where I explain the standard integral, and the very same video will pop up on the top right of the video that you're watching. Go and watch there in order for you to understand this type of integral. Right, so let's do the last one. We have negative half cosec 2x multiplied by cot 2x. So we're going to write plus half and then cosec 2x over 2. Right, let's create more space there to finish everything. Plus c. Some of you might be confused. Why do we have to have plus there? Because this is a negative there. Well, it's very simple, guys. Remember, the derivative of cosec x is actually dy over dx is actually negative cosec x multiplied by cot x. So since this one here is negative, when you go back, this is going to be positive. I hope you guys understand. Right, so we are done there. Let's not forget to add plus c. So guys, this is how you do integration of a polynomial, but we're not done because we need to simplify. So let's simplify it further. As for the first term, we have y is equaling to 4 multiplied by 5 to the power of 3x divided by 3 ln 5. There we go. And then second term, we have this 4 divided by 4, and then we only left with sine 4x. There we go. Third term, nothing you can do there. Just write it as it is, 7 tan x. Fourth term, again, nothing you can do. We just have negative pi over 2 multiplied by ln x. And then the fifth term, we have negative cos 6x divided by 6. So it's going to be negative cos 6x divided by 6. And then the sixth term, we have to simplify it further. Right, so when we simplify this term here, we have negative 4 over 15x to the power of 5 over 2. And then the last one, on the numerator, we have 1 multiplied by cosec 2x. So it's going to be cosec 2x divided by, we have this 2 and 2 multiplying each other on the denominator. We have 4 there, and then plus c. Guys, this is how you do the integration of this polynomial. Just in case you didn't understand how to do this, you can go to the point where you got lost and rewatch it there. If that doesn't help, you can always leave a comment in the comment section. I'll try to help you to my level best. Guys, we are done with 5.1. Again, I'm going to leave a playlist on polynomials on the description. Go and watch those videos where we solve problems similar to this. And also the very same playlist will pop up on the top right of the video that you're watching at the current moment. All right, people, we are done with 5.1. How about we do 5.2? All right, guys, here is our question 5.2. Now, as you can see here, 5.2, it has 5.2.1. Let's read the question and solve this problem. The question goes like this. Sketch the curve of y is equaling to 2x to the power of 3 minus 2x and show the area and the strip enclosed by the curve y is equaling to 2x to the power of 3 minus 2x and the x-axis which lies in the second quadrant. Now, they want us to sketch this graph here of the function there, and also they want us to show the area and the strip enclosed by the curve that we are going to draw. So the curve and the x-axis, those are the things that are enclosing the area. Just in case you didn't know, this is actually the cubic graph. So let me rewrite the function there. We have y is equaling to 2x cubed minus 2x. Now I want us to draw this graph. So when you draw this graph, you can start by saying when x is 0, meaning when you substitute 0 when there is x, you must find y. So let's continue. Y is going to be equaling to 2, open bracket. Instead of writing x, we're going to write 0 to the power of 3 minus 2 multiplied by 0 because we have x there. So this means that y is going to be 0. When x is 0, our y is 0. So this point here, let's call it A. Let me highlight it so that you can be able to see when you draw. This is going to be A. Now let's look at other coordinates when our y is 0. So we can say when y is equaling to 0, what is our x? So we're going to use the very same formula there or the same function in order for us to get our x values. Wherever there is y, we substitute with 0. So as you can see, if y is equaling to 2x cubed minus 2x, so instead of writing y, we're going to write 0 there, which is equaling to 2x cubed minus 2x. Now, when it's like this, we start solving for x. So as you can see, on the left-hand side is equaling to 0. On the right-hand side, we have a common factor. Our common factor here is actually 2x. If you take out 2x here, you're going to be left with only x squared minus 1, close bracket. There we go. And then from here, we can say the following. You can say 2x is equaling to 0 and x squared minus 1 is equaling to 0 as well. So we can divide by 2 here, divide by 2 there. We know that x is going to be equaling to 0. So we are fine with that. As for this one here, you can say x squared, we transpose this negative 1 to the right-hand side. This is going to become positive 1. So we're not done. So we can say x is still 0 this side. And this side here, we want x, not x squared. So what to do? We square root both sides there. But when we square root both sides, our x become x, but our 1 become plus or minus 1, right? So we need to write our points there. Let me create a little bit of space so that we can be able to write our coordinates there. So with this one, we have point B. For this one, when x is 0, y is also 0. Point C, when x is 1, or y is 0. The last point there, let's call it point D. When x is negative 1, y is going to be 0. There we go. Let me highlight them so that you can be able to remember them whenever we are drawing our graph. So we are done with x-intercept of this graph. Remember, let me just remind you, a cubic graph is supposed to look like something like this, where we have 3x coordinates sometimes. Sometimes it's 2, sometimes it's 3. As much as this graph of ours, it cuts the x-intercept, it also has the turning points, guys. So let me show you the turning points. We have this turning point there and that turning point there. So meaning we need to find the coordinates of these turning points. So again, this one, it's also not that difficult. All right, let me erase this. We're going to calculate our coordinates for turning point here on the side. We're going to do it here. Remember, when you calculate for the coordinate of the turning point, you need to derive our equation there. So let's derive it. dy over dx, right? This is going to give us 6x squared minus 2. But let's not forget that you always equate it to 0. Remember that. Then from here, we have to transpose this negative 2 to the right-hand side. So we're going to be left with 6x squared is equaling to 2. And from there, we divide by 6 throughout. As we divide by 6, on the left-hand side, we're going to be left with x squared is equaling to 1 over 3. But we are not looking for x squared. We're actually looking for x, so we have to square root both sides. As you do that, we're going to be having x is equaling to plus or minus 0,577. There we go. Now, these are our x's. We need to find the y values. So we have to say when x is equaling to, remember we have plus or minus here. let's say it's equaling to positive 0,577. What is our y? So we're going to substitute the x value here on the original equation then. So let's do it. Y is equaling to 2 open bracket 0,577 cubed minus 2 0,577. Then you have to put this on the calculator and then we find our y value. So when it's positive, we're going to find negative 0,73. There we go. So we can call this point here turning point 1. Let's create more space again. Let's call it TP1. So the coordinate here, we have 0,577 as x, and our y is going to be negative 0,73. So this is our turning point 1. Now we need to find turning point 2. We're going to do similar to what we did when we find turning point 1. So we can say when x is equaling to, this time around we put negative 0,577. What is our y? There we go. Again, we're going to use the formula, the original formula. This time around we substitute with negative 0,577. So let's do it. 2 open bracket negative 0,577 cubed minus 2 negative 0,577. There we go. Put this on the calculator. Our y is going to give us positive 0,73. Right. Let's write the coordinate of turning point 2. Let me create space. So TP2 is going to be negative 0,577 for x, and as for y is going to be 0,73. Right. Let me highlight them very quickly. We have TP1 here, we have turning point 2 there. Now what is left for us is to draw our graph. Let me create a space again so that we can be able to draw our graph. All right. We're going to draw our graph here on an empty space. So the ones that I highlighted in red, just know those are the coordinates of this cubic graph. Let me first create the Cartesian plane, and then we'll draw our graph. All right, guys. So here is our Cartesian plane. Now let's start drawing our graph. Now let's start with point A. Point A, as you can see, x is 0, y is 0. So this here is going to be our point A, right? Let's look at point B. Here's our point B. So point B and point A are the same. When x is 0, y is 0. So this is going to be point A, point B at the same time. Now let's look at point C. Point C, when x is 1, y is 0. So 1 is here and y is going to be 0 on the x-axis. Then let's look at point D. At point D, when x is negative 1, y is 0. So this here is going to be our point D, right? Because our x is negative 1 and our y is 0. Now it's time for us to draw the turning point. Let's start with turning point 1. Now turning point 1, when x is 0,57, which is very close to 0,6, our y is going to be negative 0,73. So let's start when x is 0,57. So 0,5 for x, it's somewhere there. Maybe somewhere here we can say 0,56. You take a ruler here, which is very close to 0,5, draw a line that is vertical, going upwards and downwards like this. There we go. Right. Now remember, our y is supposed to be negative 0,7. Negative 0,7 supposed to be on the negative side of y-axis, very close to the middle between negative 0,5 and negative 1. So I will put it somewhere here. There we go. So this here is going to be our turning point. Let me just call it TP1. There we go. And let's look at TP2, this one here, turning point 2. When x is negative 0,57, y is going to be positive 0,7. Negative 0,5 is somewhere here. Let me just do the line here. And then we draw a line, we extend it downwards like that. There we go. Now we need to find positive 0,73, which is in the middle between 0,5 and 1. So we can draw a line here again. That is going this way. Take a ruler, guys. When this line meets, you draw the dot there. That's where they intersect. So we can call this one TP2. Then we start connecting. As we connect, you'll see that our graph will align. So let me start from here. There we go. Guys, here's our graph. It doesn't look that beautiful, but it is our cubic graph. So this is a graph that you were supposed to draw. For the marks that it has, it really doesn't make sense, but it's a graph that you're supposed to draw. Now, remember the question says you must indicate the area and the strip that is on the second quadrant. So as you can see, here is our second quadrant. Let me show you the area that is enclosed by the curve on the second quadrant. There we go. This is our area that they're talking about. It is enclosed by the curve and the x-axis. Now let's draw the strip. When you draw the strip, guys, you just draw it inside the area that is highlighted. Just make sure you draw it inside there and highlight it. I hope you can see there, guys. So this is our strip there. And then change in x. There we go. And then you'll get your full marks. You have drawn the graph, you have indicated the area, and also you have shown the strip, so you will get full marks for doing this. We are done with 5.2.1. I hope you guys managed to understand this. It was really not that difficult. Yes, most people will get confused on this cubic graph, but they did mention that you only indicate the area on the second quadrant, which caused by the curve and the x-axis, and also show the strip. So this is how you do this one, guys. If you didn't understand, you can always watch at the point where you get lost. And if that doesn't help, you can leave a comment. I'll try to help you to my level best on the comment. But if this helps you to understand, people, do not forget to like, share, comment, and also subscribe if you haven't subscribed to the channel. Share this video to your friends who are doing the same subject. Guys, we are done with 5.2.1. Let's go and do 5.2.2. All right, guys, let's look at 5.2.2. Now, here's our question 5.2.2 there. They want us to calculate the area indicated in question 5.2.1 by means of integration. Look, guys, this is the area that we calculated earlier on 5.2.1. They want us to calculate the value of that area using integration. So let me create a space and do some calculation just next to our graph. So the graph is supposed to be seen as we do these calculations. All right, so let's start. Our equation for this graph is y is equaling to 2x cubed minus 2x. There we go. They want us to find the area by means of integration. So this one is very, very simple. We have to do the following. First of all, we need to use sigma. There we go. And then we need to find the upper limit and the lower limit. Guys, when you find the limit, it's not that difficult. You need to find the x-intercept of that area. If you look at our area that is shaded in green there, here's our x-intercept there, 0 and -1. So meaning those are our limits for this graph. When they ask you to calculate the area, only consider the x value of that area or of that indicated area. So let's go and write our upper limit. Our upper limit is the bigger number between 0 and -1. So 0 is going to be our upper limit. And then our lower limit is going to be -1, because between 0 and -1, the bigger number here, it's 0. Then inside there, we have to put in our equation that we have 2x cubed minus 2x multiplied by dx. So we need to use this here to calculate the limit. This is what we call definite integrals. Just in case you don't know much about definite integrals, guys, I made a video on definite integrals. You can go to the description and click on that video based on definite integrals. And also the very same video will pop up at the top right of the video that you're watching at the current moment. All right, people, let's continue with our calculations then. Let's say this is equaling to area. So we can say area is equaling to, open bracket, 2x to the power of 3 plus 1 divided by 3 plus 1. This is a standard integral, by the way, minus 2x to the power of 1 plus 1 divided by 1 plus 1. Close bracket there, and then the upper limit and the lower limit. Guys, you don't need to add plus c because these are definite integral, right? So let's continue. Area is going to be equaling to, open bracket. So we have 2 multiplied by x to the power of 3 plus 1. That's going to give us 4 as exponent. Divided by 3 plus 1, which is going to be 4 again. Minus, we have 2 right? We have x to the power of 1 plus 1. That's going to give us 2 divided by 2. Close bracket. And that is, we have upper limit and lower limit. Remember, these are not powers, but limits. So we can continue here and say area is equaling to, now open bracket. Now we're gonna simplify this. On the first term, we have x to the power of 4 divided by 2, because 2 divided by 4, it's half, minus, we have 2 divided by 2, then we have x squared. And then this one here, we can say is for the upper limit. You're gonna always minus by the same integral with a lower limit. So we're gonna have x to the power of 4 divided by 2 minus x squared, open bracket, now minus 1. These here, guys, are not powers, but limits. Remember, these limits here from the beginning, these limits from the beginning, we are keeping them. We are indicating that we still have this limit. So the upper limit is going to be subtracted by the lower limit. So before we continue, let me create a little bit of space here. So let's continue. So wherever there is x on the first bracket, we're going to substitute with the upper limit, which is 0. So let's do it. It's going to be open bracket 0 to the power of 4 divided by 2 minus 0 squared, minus open bracket. Wherever there's x on this bracket here, we're going to substitute with -1. So open bracket -1 to the power of 4 divided by 2 minus -1 squared, close bracket. Now we have to use our calculator. The first bracket, guys, we're going to have 0 if we use our calculator, and then we say minus. Inside this one here, we're going to have -1 over 2. So meaning our area, guys, is actually half. There we go, unit square. So I hope you guys managed to understand this. It required you guys to understand the indefinite integrals and limits as well. If you didn't understand the indefinite integrals and limits, then you're going to be struggling with this question. But basically, this is how we do this question. Again, guys, if you got stuck somewhere, you didn't understand, please rewatch at the point where you got stuck. But if you managed to understand, don't forget to like, share, and subscribe to the channel if you haven't subscribed. Guys, we are done with 5.2.2. Let's go and do 5.3. All right, guys, let's look at 5.3. Now, 5.3, we are given this expression here. They say determine sigma, open bracket, e to the power of 2x minus e to the power of 3x, close bracket, divided by e to the power of x multiplied by dx. Now, this one here, guys, before we integrate, we need to simplify. So let me simplify it first. So as we are simplifying, you keep the sigma there. Let's do the simplification. I can write it like this: e to the power of 2x divided by ex minus e to the power of 3x divided by ex, close bracket, dx. Now, using exponents, we can subtract the exponents there, since all of these have the base of e. So we can write this like this: sigma, open bracket, we have e to the power of 2x minus x. Because of this e, when it goes to the numerator, the exponent, they will subtract each other. Minus, and we have this one here with e to the power of 3 minus x again, close bracket, dx. Now, if you continue write this now can be as follow. We have e to the power of x, because 2x minus x is going to give us x, minus e to the power of 2x. Now we can say multiply by dx. When it's like this, we can start integrating. So let's integrate. Y is equaling to this one here. The first term, we have e to the power of x. This is the same as ex, no problem. And then the second one, we have e to the power of 2x. So we can write as negative e to the power of 2x, but we have to divide by the coefficient of x, which is 2, plus c. On this one, we need to include c because these are indefinite integrals. So if you continue, I'm going to continue here on top. The answer is going to be e to the power of x minus e to the power of 2x divided by 2 plus c. That's it. Some of you may wonder, why don't we have ln e? Ln e, guys, is equaling to 1. That's it. You don't have to worry about it. So this is our final answer, guys. This was straightforward, really not that difficult. All you needed to do is simplify. Again, just in case you didn't understand, you can leave a comment in the comment section. Also, you can rewatch at the point where you didn't understand. If that doesn't help, leave a comment, guys. I'll try to explain you to my level best. Guys, we're done with 5.3. Let's go into the last question of this question paper, 5.3. All right, guys, here is our 5.4. Now, 5.4, the one asked to evaluate the following here. We have the upper limit pi over 2 sigma, lower limit 0, open bracket. We have sine 2x multiplied by cosec x, close bracket. They forgot to put dx there, but basically this is how the question is supposed to be. Now, this question here, again, these are limits. I already left the video where I explained definite integration. On the description, go and click on that video. It will help you to understand what I'm doing here. So go to that video there. So first thing first, we have radians there. Rather change these radians into degrees. Now, when you change radians, pi over 2 into degrees, you multiply by 180 divided by pi. So this means that we're going to have pi divided by pi, and 180 divided by 2. This is actually 90 degrees. It's easier this way than when you use radians, right? So we can rewrite this as sigma. Instead of writing pi over 2, we can write 90 degrees, the upper limit, and the lower limit is 0. So it's fine like that. But look at what we have there. We have sine 2x. So sine 2x is a double angle identity. You can write it as 2 sine x multiplied by cos x. There we go, multiply. And then we also have cosec x. Cosec is an inverse of sine. You can write it as 1 over sine x. There we go. And then let's not forget to write dx there. Since everything is multiplying there, we can say sine divided by sine. They will give you 1 multiplied by 2 cos x. So let's rewrite this further. So we can say upper limit 90 degrees, lower limit 0, open bracket. We left with 2 cos x, closed bracket, dx. There we go. And then from here, we can start integrating this. So let's start. Y is equaling to, let's open our bracket there. Let's not forget these are indefinite integrals. So we have the coefficient, which is 2 there. So what is the integration of cos? We know that it's going to be sine x, close bracket. Then we write the upper limit and the lower limit. So when you continue here, we're going to have 2 brackets. The first bracket is for the upper limit, which is 2 sine x. And then the upper limit is 90 minus the same integral there, which is the second bracket for the lower limit, sine x, and then lower limit. So we continue on top there, guys. Wherever there is x, we substitute with our limits. So on the first bracket, we're going to have 2 sine. Instead of writing x, we're going to write 90 there. Let's not forget these limits here, guys, right? This 90 there. So minus. So on the second bracket, we're going to write 2 sine. Instead of x, we're going to put 0. Again, let's not forget this here is a lower limit, the 0. So when you put this on a calculator, this here is going to give us 2 as an answer. So this here is our limit. You can write unit square as well, because this is the formula that we use to calculate the area. So this is our final answer. Our limit here is actually 2. Guys, I hope you managed to understand how to do this question paper. This was the last question on this question paper. If you didn't understand, go to the point where you did not understand, rewatch at that point. And if that doesn't help, you can leave a comment in the comment section and I'll try to help you to my level best. If this helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. We are done with this question paper. I hope you managed to pass this question paper. And if you are revising, you can always go to the playlist. At the end of this video, I'll leave other question papers. You can click there to practice more. Thank you very much, guys, for watching. Till next time. Cheers.